feature like lighting a Raptor in space while maximizing public safety. So let's take a closer look at the flight test profile. Now, about 26 minutes from now, Super Heavy will ignite its 33 Raptor engine and lift off from the starbase. About 3 minutes into the flight, Super Heavy's booster will separate from the ship in SpaceX's second ever attempt at a hot stage separation. That means it'll light its engines while still attached to a partially lit booster. The ship's engines will then remain lit for about 6 minutes during the ascent before entering a coast phase.
Starship and you have a question about a flip maneuver and execute a boost back before or afterwards, where flight instead of having to leave the building and go and find the person. We're hoping hardware upgrades made for this flight time, sending an email, waiting for the response. Odds are you're right next to that. In the meantime, Starship goes for about 30 minutes at altitude. You're working right alongside them, so you don't have to wait 5 kilometers. And the ship will attempt to fire a single Raptor engine for our first ever relight of a Raptor engine in space. And from there, the ship will head toward its destination, splashdown location in the Indian Ocean. Again, if we get past a successful stage separation and a full ascent burn with the upper stage, it will be at an added altitude and trajectory below orbital, meaning Starship won't have to fire its Raptor engines for a orbit burn, and it will naturally come back into the atmosphere no matter what.
Now, meanwhile, the Super Heavy is going to attempt a landing burn before splashing down into the Gulf. And while we are going to practice a landing, we aren't planning to recover any of the hardware from Super Heavy or the ship on this flight. Now, with the exception of Falcon, this is no different from what happens with most rockets flying today that are expended or fall into the ocean after they complete their mission. Eventually, though, we will land and recover Starship boosters and ships, just as we do with Falcon 9 and Heavy boosters, where we've recovered 283 to date. Starship's rapid reusability is key as we begin missions to the moon and beyond.
Even though recovery is not planned, the telemetry and data we receive all the way to the end is what we're looking for, particularly with regard to the ship's temperatures during re-entry and how the heat shield will perform. The data that we gather today, of course, will help us continue to build a rapidly reusable Starship that is double the size of the Millennium. Now, much like our first 2 flight tests, and today also still just a test. Our goal is to gather data to continue iterating and ultimately itself is about 50 meters tall. And
that's exactly right. The primary goal for Flight 1 was to clear the pad, and we did that and got a lot of great data that helped us improve the vehicle and the pad infrastructure that you see today. The primary goal of Flight 2 was to get all the way to stage separation, which we did, and even got a little extra.
For Flight 3, we've added some ambitious tests highlighted by an attempt to transfer several tons of propellant between the tanks inside Starship itself, as well as the first ever relight of a Raptor engine in space, and the opening and closing of Starship's payload door. When Starship takes astronauts to the lunar surface as part of NASA's Artemis program, it will be refilled in space by a Starship tanker spacecraft before boosting itself into a lunar orbit, like you see here. Transferring a large amount of cryogenic liquid in space has never been done by anyone ever. So, we'll be looking to get data on some of the fundamental physics in play here, like managing pressures, temperatures, propellant settling, all as we prepare for eventual ship-to-ship of 18,000. The ability to refill starships once in orbit will be critical for landing on moon, and is a key technology for enabling deep space exploration and ultimately naturally, the tiles are
designed for rapid reuse. Now, we're also attempting the first ever relight of a Raptor engine in space,
as we mentioned
and
earlier,
we'll need that capability for future in-space maneuvers and deorbit burns. It's important to note that what we'll attempt today is not a burn required for Starship to re-enter on today's test. We are intentionally flying this new steeper trajectory so we can test things like engine relights without substantially changing where we expect to splash down. And if Starship manages to make it all the way to re-entry, we will collect valuable data on the vehicle as it flies through the Earth's atmosphere at hypersonic speed, or more than 5 times the speed of sound. We expect it'll look something like this animation on your screen with the heat shield tiles facing down. We'll use the Earth's atmosphere to brake the vehicle and then get us into a controllable regime as we go towards splashdown. Now, we did validate Starship's ability to fly and land at subsonic speeds during our suborbital flights several years ago, and gathering data on the aspects like heating and vehicle control while we're traveling way faster will become critical to eventually bringing starships back from space for rapid reuse.
We'll also attempt to open and close Starship's payload door for the very first time, a capability that we'll need when Starship starts flying our next generation Starlink satellites. And there you can see an animation of what that will look like as the satellites are deployed one by one here, a slot near the top.
I still remember seeing this on
at this point in time, we are approaching T-minus 21 minutes until liftoff. Let's check in with Dan for a countdown update.
Ending its flight with a soft splashdown, 7 minutes.
Hey, thanks, Kate. Hey, everybody. I'm Dan Hewitt. Good morning. Welcome to Starbase, coming to you from the Raptor's Nest, where I'm here with some of our flight controllers, also our Pad Red team. We're just behind the Mega Bay. Those are super heavy boosters right behind me, getting ready for the next 4 flights after this one. So we're looking to launch a lot this year. Countdown has been pretty clean so far. We're not tracking any issues that are gating us on the hardware side and the vehicle side from that on-time liftoff at 8:25 a.m. Central Time. That's our T0 right now. We primarily shifted later as we were just working to clear the range. The other big watch item today is going to be the winds. The winds have started to pick up. We're still looking to be below our limits, but there could be a hold at T-minus 40 seconds just to make sure that the winds are acceptable before we go. We are actively loading propellant on board the vehicle. You can see by the frost line starting to build up. Looks like we're about 80% on the ship main tanks right now, and a little over 60% on the booster.
Ocean.
Now, Starship uses liquid methane as its fuel, liquid oxygen as its oxidizer. Both of those get cooled down to cryogenic temperatures, so several hundred degrees below zero. And if you follow along with our previous 2 flight tests, the prop load timeline today looks a little bit different. Those first flight tests took us about 90 minutes to load all of the prop on board, but since the second flight, we made some pretty significant upgrades to make that time shorter. We added some additional fuel and launch pumps just to increase our capacity. We expanded the number of heat exchangers and installed a dedicated fill drain line for each stage, but they were sharing one before, now they each have their own. That's just that main pathway to get the propellant to the vehicle. We're aiming for about 51 minutes for today's operation to fully load prop. We did that successfully on our wet dress rehearsal that we did recently. Eventually, though, we're trying to get that time down to about 40 minutes. Just for some context, that's about 5 minutes longer than we take on Falcon 9, but we're doing it with 10 times the amount of
ship's
propellant.
engines will remain lit
now,
for
the
just
propellant
under
load
6
on
minutes
ship started at about T-minus 53 minutes, booster right around T-minus 42 minutes. We are about to pause loading on the main tanks of ship, switch over to the header tanks, and then switch back to close out the main tanks. We're expecting all of the prop to be on ship at about T-minus 3 minutes 30 seconds, and then booster prop load ends at T-minus 2 minutes and 50 seconds. Now, our final countdown and startup sequence is going to be the same as Flight 2. We already tested this on this booster when we did it static fire.
And ship have to contend
Looking
with
back
some
for Flight
extreme
1,
conditions
we
on
lit those
re-entry,
Raptor engines on the booster and lifted off about 6 seconds later. Flight 2, we reduced that time by almost 2 seconds. That just helps reduce the stress.
With the exception of Falcon, this is no different than what happens to most rockets flying today that are suspended, meaning that they fall into the ocean after completing their mission. Eventually, we will return and reuse Super Heavy boosters and Starships as we do today with Falcon 9 and Falcon Heavy boosters. And in fact, we've landed Falcon boosters
if we can't make our test today, we have backup launch opportunities in the coming days.
I hear you say that number,
24 to 48 hours, all just depends on how far we get into the count.
Or at least most of the night.
Check back in with everybody in just a little bit. For now, though, I'm going to send it back to Kate and Shiva out at Hawthorne.
Yesterday.
Yeah, definitely one of my favorite moments
at SpaceX. The countdown is continuing to progress, so let's take a closer look at the world's most powerful launch vehicle ever developed. Starship is comprised of
rapid reusability.
Yeah, speaking of rapid reusability, future Starship designs
which has
will give
33
Super Heavy
Raptor
boosters
engines.
a lighter weight
Starship is capable of about twice the thrust of the Saturn V rocket, and with future engine upgrades, it will actually be 3 times as more.
Similarly,
3 times
even
more
though ship recovery is
now,
not expected,
with those future improvements, that'll allow Starship to carry somewhere between 150 and 250 metric tons to orbit, depending on the configuration. For reference, Falcon 9's heaviest payload to date is just over 17 metric tons. So with Starship, we're talking about an order of magnitude greater in terms of payload capability to orbit. And that matters because the amount of mass we're able to launch per rocket is critical to creating
a few kilometers from Starship on the pad. How's it going, Dan?
In terms of size, the Super Heavy booster alone stands about 71 meters or 233 feet tall, and is about the same height as a fully integrated Falcon 9. The ship stands about 50 meters or 160 feet tall. Stacked together, the booster and the ship are by far taller than the Statue of Liberty, which stands at 305 feet tall with its base. Stacked together, Starship is 396 feet, so quite a bit taller there.
Now, Starship's first stage has a diameter that's about 2.5 times that of Falcon 9, and we've got those 33 much larger Raptor engines, this great view of the launch mount looking up at those engines, and we need them to power through the Earth's atmosphere and gravity to deliver those massive cargo and payloads up to space. Moving up the rocket, Starship is designed for vertical takeoff and landing on any hard surface, and that's as opposed to taking off and landing on a runway as aircraft do. And that's important because there are no runways on the Moon and Mars where we're going. The ship, which we're looking at now, features 6 Raptor engines. 3 of them are sea-level engines, 3 of them are vacuum engines. That means that those vacuum engines are optimized with a larger engine nozzle to operate in the vacuum of space and get us higher performance.
The ship is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable a precision landing. The body of Starship is also wrapped in a heat shield made up of 18,000 hexagonal ceramic tiles. Those are designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit. One of our test objectives today is to verify how Starship systems and thermal protection system tiles perform during reentry. And in between the first and second stages is our hot stage, which is critical for our newest separation technique, which we saw in action during Flight Test 2.
Yeah, that was a pretty exciting first for our team. Hot staging had never been done before as part of a reusable space transportation system, let alone on a vehicle with the size and power of Starship. Now, at about liftoff plus 2.5 minutes, the booster shut down most of its 33 engines, leaving just 3 of them running, and then the ship simultaneously ignited all 6 of its engines. Some clamps separated, and the ship thrusted away. That was the first in-flight test of the heat shield, and we were able to gather a ton of valuable data about hot staging.
We've developed
we maximize the vehicle's performance by leaving 3 first-stage engines on, so gravity can't rob us of precious velocity, or at least not as much. Hot staging also helps to ensure the ship's liquid propellants are at the bottom of the propellant tanks, which is where we need them to be in order to quickly light the ship's engines. It also reduces risk at stage separation because it creates a passive staging system, so that physics will be doing the work instead of mechanical parts pushing the 2 stages away from each other. Ultimately, hot staging could increase Starship's payload-to-orbit capacity by 10%, which directly translates to more payload and more people to the Moon and Mars.
That need to be met. There are 3 primary
the first
gates
stop
that will
be the
in
Moon, and the SpaceX team has been hard at work proving out all the systems necessary to make that possible. Critical systems for propulsion, life support, and even the elevator that you see here, which will take crew and cargo from the Starship hatches down to the lunar surface, are currently in development. And the data that we gather from each test flight helps inform their design. Here we've got a photo of some of the mock-up suits that are used to demonstrate the range of mobility that astronauts will be expected to have, and we were using these to do human factors demonstrations and figure out the layout of the elevator. So all awesome development work for a future Moon mission.
Super cool. Now, SpaceX will perform one uncrewed demonstration flight before NASA's Artemis 3 mission, which will be the first human surface expedition since 1972. After those first expeditions, we'll be ready to fly more people along with everything it takes to build a moon base. There's so much to look forward to. It's incredible that humans are finally going back to the moon.
You couldn't have said it better, Kate. And the Moon is just the proving ground. It's just the start. When the time comes to make the leap to Mars, everything ramps up by orders of magnitude. The logistics of supporting an entire city on Mars are daunting and will require millions of pounds of cargo flown from Earth and spread out over thousands of launches.
Are you thinking what I'm thinking?
And today's flight test is one more step toward that ultimate goal.
I was going to say excitement.
Currently at T-minus 11 minutes, 47 seconds. Let's check in with Dan once again for a countdown update. Super Heavy may generate a sonic boom upon its return. And that's basically
still good news from down here at Starbase. We're not tracking any technical issues that are going to block us to a launch. Our T0 time still holding to 8:25 a.m. Central, so just about 11.5 minutes from now. The real thing we're going to keep an eye on is the winds once we get there. We do have that potential hold at T minus 40 seconds where we can hang out and either let winds die down, make sure we're in the right structural limits, everything like that. So don't be surprised if we do a hold at T minus 40. We've done those on previous flights, but we are not tracking any technical issues. The range is going to be green for launch, so all that really great news. We're still loading propellant on the vehicle, on the ship. We're just about done loading the header tanks, the two smaller tanks at the top, and then we'll go back to the main tanks. They're about 85% full, and then booster, both fuel and LOX over 80%. So looking good there. The launch pad itself is getting ready for liftoff. We commanded the booster hold downs open already.
That thunderclap broke the sound barrier.
Type booster separation confirmed.
Just heard the two sonic booms here in the room.
Booster lane confirmed.
La starship. Déjame agrandar un poco la pantalla.
As our test flights continue, we plan to demonstrate ship-to-ship propellant transfer, which will be important in preparation for Starship taking astronauts to the moon as part of NASA's Artemis program. SpaceX will perform one uncrewed demonstration flight before NASA's Artemis 3 mission, which will be the first human surface expedition since 1972. Also in preparation for missions to the moon and Mars, we're gaining tons of knowledge from our human spaceflight missions, including free flyer flights like our recent commercial astronaut mission Polaris Dawn.
Polaris Dawn was the first of up to 3 missions in the Polaris program, which is demonstrating new technologies, conducting extensive research, and will culminate in a flight of Starship with humans on board.
After nearly 5 days in orbit, Dragon and the 4-person Polaris Dawn crew safely splashed down on September 15th off the coast of Florida, completing the first human spaceflight mission of the Polaris program. The Polaris Dawn crew performed some incredible firsts during their mission. Dragon and the crew reached 1,408.1 kilometers, the highest Earth orbit ever flown, and the farthest humans have been from our planet since the Apollo program.
The crew also performed the first ever commercial EVA, or extravehicular activity. And as you can see there, they were wearing the new EVA suits that we developed here in-house. This was an incredible moment to see Jared and then later Sarah emerge and perform this EVA with Earth behind. Now, in addition to this incredible spacewalk, they also conducted about 36 research studies and experiments from 31 partner institutions, including NASA. And in addition to all of that, they also tested Starlink laser-based communications in space. The data gathered from Polaris Dawn missions is invaluable, much like the data that we're going to see after today's flight test of Starship. So we're coming down to T-minus about 7 minutes. Let's check in with Dan.
Hey, thanks, Kate. So yeah, we're right at about 7 minutes away from launch. The main thing we are still working is that range clear. Again, we have to make sure boats, airspace, everything is cleared out of the way for our ascent corridor, basically the Gulf of Mexico, where we're launching through before we can actually launch. And so we're working on clearing out just a few more boats. We do have a window, remember. So if we end up holding at like a T-minus 40 seconds, we can hold for several minutes, allow those boats to get out of the way, and then we can launch. Our window is from 7 to 7:30 Central, so
they teach us about the limits of our design and improve our understanding of the vehicle, and ultimately help us make Starship more reliable and rapidly reusable. So whatever the outcome and however far we get, we can promise excitement. And things look like they are moving fast at Starbase, and that's exactly how we like it. Rapid iteration is a key of SpaceX.
Yeah, we've done it with all of our major innovative advancements, including Falcon, Dragon, and Starlink. We believe that if you're not failing, you're not learning and improving the design.
Yeah, many of the innovations that we've developed have come from our failures, and they teach us how to avoid the perils of spaceflight. It's a tough business. But all of this testing, all of the iterative design allows us to make the design better and better to do some of the great accomplishments with reflight that we've had so far.
Exactly. One of the examples that we love to talk about is the Dragon capsule, like the one located behind Shiva and I here on the mezzanine. Originally,
otherwise, if we don't go today, as you guys
originally
talked about,
it was not designed to be reusable. We wanted to prove the initial design, and then when we brought Dragon 2 online, we had to do a lot of corrosion analysis based on flights that had splashed down and analysis on hardware received there. And now our Dragons are reusable and also rapidly at a much rapid pace than they used to be.
Yeah. So I mean, great learnings from our original Dragon to our new crew and cargo vehicles have directly improved the operations, and they've helped us change our understanding of what's possible when it comes to rocket and spacecraft reusability.
Our rapid
now we're just under T-minus 6 minutes, so I think it's another good time to check in with Dan for the rest of terminal count. How are you looking, Dan?
Dragon and Starlink. Today, we're testing
Big
hardware
Shiver, we're
and
looking
systems,
good. 5 minutes, 35 seconds, and we're counting down. We are just about at closing the prop load sequences on booster and ship. Just a reminder, ship we're going to close out at around 3 minutes and 30 seconds, booster at about 2 minutes and 50 seconds. Once all of that prop is loaded on board, we'll have about 10 million pounds of propellant on both stages of Starship. Now, after that happens, we'll go through a couple of different procedures with the ground. We'll do what's called pushbacks, clearing out the lines between our prop farm and the vehicles themselves before we get to launch. And then in the next few minutes, we'll get the final guidance system alignment, some final thrust vector control on the booster checks, and all that will be performed. And again, if we need to hold, we have a hold gate built in at T-minus 40 seconds where we can hang out. It sounds like today we'll have about 15 minutes to hold at T-minus 40 if we need to. If we hit that right now, it looks like the most likely reason would be winds. We're not tracking any technical issues to our T0 at 8:25. Just
and
about
providing
4
free
and a half
service through the
minutes
end
from
of the
now.
year to support
So,
recovery
I mean,
efforts.
everything's really
The
looking
Starlink
good.
team also worked with
The
T-Mobile
booster's
to
almost at
activate
full
our
frosty, so
direct-to-cell
we'll see
satellites
that
to
close out
provide
in just a
basic
couple
texting
of
on
minutes.
T-Mobile
But
and emergency
we're getting
alerts
really
for
close to
all
flight,
phones
guys.
and carriers of those in affected areas.
The excitement is
If a phone
definitely
connects to a
growing
Starlink
here
satellite, it will
in
have
Hawthorne,
1 to 2
SpaceX
bars of
headquarters.
signal and show T-Mobile SpaceX in the network.
45 minutos
SpaceX's direct-to-cell constellation has not
5 horas
been
y
fully
45
deployed,
minutos para el
so these
despegue.
services are being
Muchas gracias.
delivered on a best effort basis.
Starlink is enabling life-saving communication here on Earth and continues to help us push the limits in space. In the short term, by providing great views and real-time data on our next few flights, particularly through re-entry, which historically is a blackout period for all communications.
All right, so we're coming up on 2 minutes, 30 seconds away from launch. We were hearing like there was a pretty good chance we were going to hold at T-minus 40 seconds, but surprise, now it sounds like we might not be. So we are just a little over 2 minutes away, so a couple more things going to be happening. We did just close out our propellant load on the ship and the booster, so 10 million pounds of propellant on that vehicle on the pad here at Starbase, getting ready to go. We're going to start clearing out all of the lines that are basically pushing all of that propellant to the vehicles. Those get cleaned out or cleared out on the ground before we lift off. We're doing some final checks on the vehicle, the thrust vector control that we're going to use to steer it, as well as the guidance system doing its final alignment, just a lot of our final checkouts. But we are starting to hear that it looks like the range is going to be clear at our liftoff time of 7:25 a.m. Central, 12:25 UTC. So that puts us 1 minute, 20 seconds away from launch. Still not tracking any technical issues. That range clear is the only thing that's been potentially poking at our launch. So I'm going to start to quiet down. We'll hear our flight director for today, Tristan Pierce, give some of the final call-outs. As of right now, we are 1 minute away from liftoff.
Venimos a presentar ahora mismo, no a presentar yo no soy de SpaceX, pero apoyo SpaceX. Con esto, solo hay que darle un poco de paciencia. Los motores Raptor, que son unos motores de la Starship. Recuerda que la Starship tiene 33 motores, un poquito más que la nave soviética. Bueno, el Raptor, acá dice, es reusable, el Raptor, y tiene oxígeno para la combustión. Se usa, mira, el Falcon 9 tiene el Merlin, la Starship tiene, ¿cómo lo explico? Tiene en el propulsor Super Heavy los 33 motores, y en la Starship tienen como 4 o 6, no sé, algo parecido. Y esto es el diámetro 1,3 metros o 4,2 pies. El largo 2,9 metros o 9,5 pies. Y acá está el empuje. Yo no lo sé leer en inglés y español, no lo sé, lo siento, soy niño aún. Pero la Starship por ahora, por ejemplo, se usó cuando capturaron el Super Heavy. También quieren hacer para transferir combustible desde el espacio, algo que nunca se ha podido hacer. Por eso, acá está la Star Factory, las oficinas de SpaceX. Acá está los lanzamientos de prueba. Son una versión de Starship de prueba, como lo que pasó lo mismo que con el Artemis 2, así. Y bueno, después les voy a presentar más sobre el Falcon Heavy. Ya saben, ya. Y también después les vamos a presentar el Dragon y el Falcon 9. Bueno, acá van a ver después esto y todo. Bueno, ahí los dejo. Hagan lo que quieran. Chaito. Recuerden que después el lanzamiento lo vamos a ver por la página oficial de SpaceX, y también ustedes pueden ir a buscar SpaceX, SpaceX.com, www.spacex.com barra vehicles barra Starship, y después se pueden encontrar una parte que dice Upcoming Launch, y van a estar uno que dice Starship 12 Flight Test, y el que quedan 5 horas con 38 minutos o lo que sea que le quede, el que dice Starship, no el de Starlink Mission. Bueno, continúen. Gracias por las 10 visualizaciones.
booster. We were hoping that the booster would perform a soft water landing, but we lost it during just before it was able to ignite the landing burn. But the ship continued on. We saw all six Raptor engines on the ship ignite and then shut down for second engine cutoff. And we saw some amazing views as well, and it's just been certainly a day that I will be taking many screenshots and using them as my computer desktop background for, well, until the next Starship launch.
When we get even better views, I'm sure.
Exactly.
And we also hit a number of our other ambitious test objectives. We had a chance to at least initiate the commands for a propellant transfer demo within the vehicle. This is something that Starship's going to have to do in the future, and these sort of transfers haven't been done at this scale before. The first as well. We also were able to demonstrate that the payload door functions.
And we got to see that,
And so those commands were sent. Again, data review to come and make sure that everything performed as expected, but that's going to be critical to deploying payloads in the future once Starship becomes operational. So a number of test objectives hit, much more accomplished than Flight 2, and making steady progress towards a fully, rapidly reusable, reliable Starship.
Absolutely.
And hey, Kate, and hey, Shiva, we were just hearing on the loops, we are making the call now that we have lost Ship 28. So as we were possibly expecting, we lost the data a couple of minutes ago. We haven't heard from the ship up until this point, and so the team has made the call that ship has been lost. So no splashdown today, but again, just it's incredible to see how much further we got this time around. We had a couple of those ambitious objectives that you guys were just walking through that we're able to take advantage of while Starship was in outer space flying over our planet for the very first time. So that was just really incredible. Obviously, there's a lot to go through. Everyone always wants to know right off the bat what happened. Takes us a little bit of time. But I can assure you, as soon as we start finding things out, we're going to let everybody know. And I know everybody's going to be excited for the next one. I mean, as I pointed out in the beginning, there's 4 super heavy boosters either fully stacked or getting stacked right behind me. We've got other ships ready to go as well. So it's going to be a really busy time down here at Starbase as we look to really fly Starship as much as possible, get this vehicle ready to go for all the important things it's got to go do.
And with that, we got to say a huge congratulations to our teammates and everyone who's supported the Starship program. There's been flames and reds along the way, but third time's the charm, and we made it to space. We also a big thanks to all of our future customers for your support. And we want to give a big thanks to the people of Cameron County, Texas, for their support, as well as the Coast Guard and the Federal Aviation Administration.
Be sure to follow the SpaceX account on X for more updates from today's test flight and future Starship tests. But before we go, we want to wish SpaceX a very happy birthday. The company was founded on this day in 2002 when it basically consisted of this small team, a carpet and a mariachi band. I don't know about you, but we're feeling 22. Also, it's Pi Day.
Yeah, but I mean, Pi Day is constant and never ending, so shouldn't every day be Pi Day from now on?
I mean, that's a really good point, and I think after a test like today's, we all deserve some pie.
Thanks for watching, and we'll see you next time.
4 horas con 15 minutos para el despliegue.
And so those pieces, which at the time did not seem small at all, were Falcon 1, Falcon 9, Dragon, both cargo and crew, Falcon Heavy.
Falcon Heavy is supersonic.
These were the building blocks that let us cut our teeth on learning how to do rockets. Not the way the aerospace industry had been doing it, but the way we needed to do it to end up here where we are today working on Starship.
10 minutos más y vemos cómo funciona el Falcon Heavy.
Version 3 is what I like to call the foundational design of Starship booster in the pad. That's going to give us the new capabilities we need to do the missions in front of us. It'll be the one that puts humans back on the moon. It'll be the ones that put the first blueprints and then city on Mars. Starship is giant, and that scale is not an accident. It's not to win some Guinness World Record prize, which we did for both the ship and the tower. It's because we need that size to do the things we dream of doing with it.
Ship 39 is the first V3 rocket. This rocket is unlike anything anybody's ever done before. Version 3 is basically a clean sheet design of the ship. We essentially took a bunch of lessons from version 1 and version 2, and we took a step back and said, what were the things that were really problematic, either from a performance perspective or from a reliability perspective on the previous rockets? And then we directly addressed those with a variety of new designs. It can go up to orbit, it can stay on orbit for 48 hours, it can meet up with other ships, and it can do propellant transfers, which is really the core technology that you need to unlock Starship. Once you unlock that capability, the whole solar system is on your doorstep. And right now what we're doing is we're actually going through checkouts, so we're actually kind of bringing the rocket to life.
We've never built a Ship V3 before and gotten it to this state of production. So we are going to have special things to this specific vehicle that are going to be odd, but there's also things about the architecture as a whole that we don't really know how to deal with because we've only done simulations, we've only built fluid models of how we think a Ship V3 operates. Now we have the real deal next to us.
First priority is your safety, the second priority is make sure the vehicle's okay, and then we worry about executing to our schedule.
We're quite excited, we're quite anxious, but all things considered, we're pretty well prepared. We think that we'll have a good result.
We intentionally started Starship with the ship portion because it was so novel. We have done a reusable booster before with Falcon 9, and so it's at least a little bit better tread ground. I will say, I think the booster turned out to be a lot harder than we gave it credit for.
This is an entirely new rocket. This is the most ambitious vehicle design I have ever personally worked on, and it is a wild thing to see come to reality here. The version 1 flight test campaign really exemplifies the rapid integrated test style that we do in SpaceX engineering. It took us 5 flights from our first attempt, from Flight 1 to Flight 5, to successfully catch a booster, which was honestly mind-blowing. Flight 1 was able to get off the pad successfully. It proved that we could get this full system together, and we learned a lot from the eventual failure of the vehicle in that flight. We were able to put together a lot of improvements on the launch pad and on the vehicle hardware design that led to much better success in Flight 2. We were able to make it with the booster to MECO. We were able to separate the ship, and we were able to begin boosting back towards the launch site. So we hit the next big milestone in the flight test campaign. On Flight 3, we were able to get all the way through our boost back burn. On Flight 4, we were able to do a successful water landing demonstration. And on Flight 5, we were able to come back to our launch site and successfully catch the vehicle with our chopsticks. To be able to go fly that and have complete mission success at that point of we got the payload to orbit and we landed that rocket was incredible. I'm getting goosebumps talking about it now. We're about to get into a really exciting period of the vehicle test campaign here, putting the thing through its paces and making sure that everything we design works okay. Stop right here. We get all of the pieces of the system working together for the first time, and if we're going to learn anything from that, we'll learn it as quickly as we possibly can. Booster 19 is actually the second of the version 3 boosters that we've built. Booster 18 came before it. We had an unfortunate anomaly during our first test campaign of the Booster 18 vehicle. This is the first version 3 booster that we built, so this is Booster 18. This is really awesome because it's going to be our first full vehicle level operation and test with a version 3 vehicle. So the whole team's very excited about this. Sure hope it works. When we were pressing the nitrogen system, we had an explosion that took out the rocket, and thankfully we had designed that test to be safe. If something like that happened, we did not have propellants or reactive things on the vehicle, and so the test site incurred very little damage, and of course nobody was hurt in the incident.
Yeah, as part of testing, this is loud, so you learn to not be super skittish as you're walking around. So we have our booster here on site. We're going to be performing a cryo-proof. It's actually a really long day, so it's nominally planned to be a 12-hour overall prop load and offload. It's just a ton of propellant that we're putting on the vehicle, and we do a bunch of test cases throughout the whole day, so it's a long one.
Taking booster SM to cryo high fill proof.
Cryo proof is the first time you actually put.
Ok, nos vamos a poner ahora a ver el Falcon Heavy. Se han completado 12 misiones. Y acá pueden ver un poco más informaciones que no les voy a leer porque no son tan relevantes por ahora. El Falcon Heavy fue hecho como que juntaron 3 Falcon 9. Juntaron 3 Falcon 9. Ahora estos son como los propulsores. Ya que antes el Falcon 9 antes tenía una solamente parte. Y tenía como un precio a la Starship. Mira, acá así es como una vista previa del Falcon Heavy. No se suele usar mucho porque suelen casi siempre recurrir al Falcon 9. Y mira acá, 70 metros o 229 pies, 12,2 metros, 39,9 pies, una cantidad altísima de kilogramos. 73,800 kilogramos o 140,60 hay 660 libras. Y ahora van a ver esto, pero esto es importante porque el plan de SpaceX es llegar a Marte. Falta la primera parte. ¿Ves? Esta acá sale. Si quieren leerlo, tradúzcanlo. Bueno, ahí. La interetapa. La segunda stage. La famosísima imagen del propulsor, como digo, del motor. Y el payload, donde estuvo el famosísimo Starman. No vamos a ver el video. Y acá sale un poco. Y acá sale el Merlin, el que usa el Falcon 9. Y esto es serio por ahora. Muchas gracias por escuchar un poquito de esto. Después vamos a ver el Falcon 9. Ya saben, el Falcon 9. Pueden hacer lo que quieran por ahora, mientras transmitimos en vivo el directo. Muchas gracias. También gracias a los de Kik. Comenzamos a transmitir hace poquito en Kik de nuevo. Y bueno, muchas gracias. Chaito.
Static fire is the culmination of the engineering process. We are bringing all of the pieces of the puzzle together, and we are lighting the engines. And if you make it through that, you have pretty good confidence that you're in a good position to go fly.
Aboard. On LVN1, looks like we kicked out 2 combustors from the apex bank being pelted.
Looks like we have to engine time of 2.135 seconds.
We successfully lit all 10 engines. They were ramping up to power. Everything was looking good, stage and engines combined. However, there was a pad side abort called. So what that means is some sort of sensor tripped, and from there we command a fast shutdown.
It was a hard one, and especially since we had to drop all the engines afterwards, and thankfully 10 of them were salvageable, which is good.
We saw some data right after static fire that showed about half the engines had what looked like mechanical damage, basically as a result of the really fast shutdown. So we brought the booster back to Mega Bay, We then decided to remove all 10 engines from the booster so that we could troubleshoot and understand what's going on those 10 while still making progress on B-19 by backfilling engines from B-20.
All right, attention all operators on LVN-1. Today's main objective is a 33-engine static fire on B-19. Okay, go no-go poll coming up in 1 minute.
So we're doing our static fire today with all 33 engines.
This is the final go no-go poll for today's operations. Flight software?
Go.
AY?
Go.
Raptor?
Go.
Stage?
Go.
CE?
Go.
GC2?
Go.
GC1?
Go.
FC1?
Go.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, mission.
Wow.
We kicked out early. All teams triage alerts, prepare for offload.
Today we aborted our second attempt of the B-19 full count static fire. We actually had another pad abort on the diverter. We made it through engine startup and then ultimately lost some of our sensors on one of the ramp manifolds. It basically said that the manifold pressure was lower than we believe that it probably was, and it kicked us out at T plus 1.88 seconds. It's just tough because there are some things that are hard to test ahead of time. So the diverter, you can test as much as you want, but you can't obviously test for what theoretical vibe and environment you're going to see when the engines are turned on.
Anytime that you walk into an operation where you want to turn on 33 of these enormously powerful engines and get them all to work together and walk away from it in one piece, that is a win.
I think every test is always a success, and we had a bunch of findings on the ground systems, the vehicle, and the engines that I think were really good to flag at this point, but definitely a bittersweet day.
We have a saying called "only the paranoid survive." The idea behind it is that there's an enormous amount of information and data that's coming to you, and if you can use that wisely, you can usually use that to figure out where things are going to go wrong in the future. And almost every time that we fail something or have something go awry, there were clues in previous data and previous operations that if you had known what to look for and had been good enough and paranoid enough to do so, could have found it there.
Vamos a seguir con algunas cosas y sigan viendo el lanzamiento de la Starship anteriores vuelos. Muchas gracias.
It's been 10 months since Massey's had the S-36 anomaly.
Ship 36 was a tough one. We had a CPV explode, and it not only took out the rocket, but it took out a lot of the test site infrastructure over at Massey's.
How do we go make sure if we have an anomaly again, the pad can take a beating and still survive?
Losing a rocket is one thing. We've got a production line for rockets and we can go make more. Losing the physical infrastructure of the launch pad or the test site is very difficult because you need to go repair that over a period of many months before you can get back into testing. Now we have Massey's back online here. We've really, built this rocket from scratch, but we've also built the pad from scratch, so it's all kinds of new systems. This will be the first time that we bring together the pad and vehicle pieces to make sure that they all work.
Static fire vehicle is in pre-pad clear, about to get to our static fire pad cleared op state.
We run 60 seconds on ship because you get to see how the vehicle thermals all shake out and just general vehicle performance.
That if you can make it through that you're in a reasonable position to go fly.
+10.
The journey of SpaceX is a journey to give humans access to the solar system and beyond, which is really the goal for Starship.
+20.
The impact that this rocket is going to have on the world, I don't think most people can really comprehend the change it's going to have.
+30.
This is such a wild ride. The highs are high and the lows are low as we really work to get to ultimately launching people, which is going to be amazing.
+40.
It is not impossible just because it's far beyond what has been done before. We've proved that time and time again.
+50. Full duration.
It is 6:54 a.m. in Starbase, Texas, a gorgeous sunrise, and Starship is targeting liftoff in just 30 minutes and 18 seconds from now at 7:25 a.m. Central Time. As you can see, it is a beautiful day in South Texas for the 5th flight test of Starship. Good morning, Star people. I'm Kate Tice.
And I'm Jesse Anderson, and we are joining you live from SpaceX Hawthorne with a great big crowd here this morning. It's been roughly 4 months since our last Starship flight, and we've got a big morning ahead of us.
Flight 5, has a few primary objectives and one big first. We may be attempting to catch the Super Heavy booster. The teams at Starbase have been hard at work around the clock, upgrading hardware across the entire tower with focus on the chopsticks, the 2 mechanical arms that will reach out and catch the returning booster. We're only going to attempt the catch if everything on the booster and tower checks out after launch, but either way, excitement is definitely guaranteed.
Definitely. Today's Starship features a completely reworked heat shield with stronger tiles and a secondary layer, which is an extra layer of protection for the ship that will protect from any of the that will help protect if there's any missing or damaged tiles. Now, not only did we replace the entire heat shield with our newest generation of stronger tiles for today's flight, we'll also be flying a handful of aluminum tiles that are there to help the team understand the thermodynamic environment during reentry. If you were with us for Flight 4, you'll know how hard those heat shield tiles worked during the ship's reentry.
Did they ever? As you can see there, they worked incredibly hard. This big heat shield rework that we're talking about promises to increase the likelihood of Starship being better protected during controlled reentry as it heads towards its flip maneuver and landing burn for a soft splashdown on target in the Indian Ocean, just like we did in Flight 4. And we'll have to wait and see. Keep your fingers crossed, but we may have some new views in store for you today as well.
Right, like all test flights, we want to learn as much as possible, and views of Starship during all phases of flight help us to keep improving the vehicle for recovery and reuse.
Now, thinking forward to when Starship is flying regularly, it will take the heaviest payloads to space, land humans on the moon again after more than half a century, and ultimately fly people further into space than ever before. And getting there will require us to rapidly iterate and fly often, which is why we're working so hard to scale operations at Starbase.
Yeah, the faster that we learn now, the faster we can improve and evolve Starship to achieve reliable flights and rapid reusability. We've been designing this vehicle from day one to realize a vision of having an entire city of people on Mars, something we know will take launching millions of pounds of cargo and equipment into space spread across thousands of flights. This future will require many Starships that can fly again and again, and today's flight is a critical step on that path.
So buckle up your seatbelts because here we go. The moon and Mars are not nearly as far in the future as you may think. In fact, we're planning to send Starships to Mars as soon as 2026.
You might be familiar with the Starlink logo, and there you can see it on your screen. It's an iconic representation of the Mars Transfer Orbit, also called the Home and Transfer Orbit. This is how fundamental Mars is to SpaceX. This transfer window, or a time when the Earth and Mars are the closest to each other, opens every 26 months and is only open for about 2 to 3 months at a time for a vehicle with Starship's power. And it just so happens that the next Mars transfer window opens in 2 years towards the end of 2026.
Yeah, lining up a launch to Mars is similar to how we launched to the International Space Station, where we time launches to match the station's orbit. If we didn't do this, we'd need more propellant and more time to get there.
Exactly. So the first opportunity that we have to fly Starships to Mars, we plan on doing it. These first flights to Mars will be uncrewed and will test the reliability of landing intact. If those landings go well, the first crewed flights will follow soon after.
So it's safe to say it's all happening, and flights like today's are what's going to get us there. Not only have we made several improvements to the Starship flying today based on what we've learned from our last flight, including extensive upgrades to Starship's hardware and software, we've also made improvements to the launch tower and catch mechanisms.
And if you've noticed in some of the live views this morning, our teams have completed stacking the second launch tower, which will be coming online next year. Having 2 operational launch towers paired with ships and boosters rolling off the line in our new Star Factory will allow us to increase our flight cadence and test even more rapidly. And just a few miles away from the 2 towers, things are moving really fast at the heart of Starbase. Star Factory is rapidly coming online, with production teams already using the space as construction continues. The 1 million square foot Star Factory brings many parts of the manufacturing process under one roof for the first time, enabling moving as much system integration work as possible earlier in the build process, with the goal of eventually producing hundreds of starships a year.
That's crazy. It's such an impressive building. So, for example, teams can assemble an entire nose cone structure of a ship into a single piece and work on its internal systems all in one place. So if you're working on Starship and you have a question about the steps that you're working that happen before or after yours, instead of having to leave the building and go and find the person or the team with the answer or waste time sending an email and waiting for their response, odds are you're right next to that person or team, and now you're working right alongside them, so you don't have to wait for a response.
Yeah, exactly. It makes it a lot more efficient and faster to communicate. So not only are we rapidly iterating on these spacecraft themselves, but we're also innovating the way that they're made.
It's almost too much to keep up with.
We're also posting updates on our account on X. If you can't keep up, that'll help you. So if you don't already, make sure that you follow us at SpaceX on X. And I have a feeling it's going to get pretty busy.
Oh, that is definitely an understatement.
And it's definitely going to be very exciting today. So with that, let's meet today's Starship on the pad. Starship features two major parts, the ship, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. The current iteration of Starship is essentially an experimental vehicle flying forward development. With a few planned upgrades, Starship will have 3 times the thrust of Saturn V, plus the added benefit of full reusability. Starship 2 will be capable of carrying more than 100 tons to orbit, and Starship 3 will be able to lift more than 200 tons to orbit. The amount of mass we're able to launch per rocket is crucial to creating a self-sustaining city on Mars.
Now, to get a sense of how big Starship is, let's start with the average size human, which is about 2 meters high. Towering over our average human is the length of the Millennium Falcon, which comes in at 35 meters. Our Falcon 9 rocket, with the payload fairing attached, is double the size of the Millennium Falcon, standing at 70 meters. And nearly twice the size of that is the fully integrated Starship at 121 meters tall. The ship itself is about 50 meters tall, and the Super Heavy booster alone stands about 71 meters. And even crazier, eventually the ship and booster will get even taller with future design iterations.
Can't imagine it being taller than that. Starship's first stage has a diameter of roughly 2.5 times that of Falcon 9, and with 33 much larger Raptor engines, which you can see there on your screen. Moving up the vehicle, the ship features 6 Raptors, 3 sea-level engines, and 3 vacuum engines, which are optimized to operate in the vacuum of space. The ship is designed for vertical takeoff and landing on any hard surface, like the surface of the moon. The ship is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable a precision landing.
To reach full reusability, ship must survive entry not just once, but over and over again. It took the teams at SpaceX about 3 years to develop the heat shield on Starship, and development for improvements is still ongoing. The ship's heat shield is composed of 18,000 hexagonal ceramic tiles designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit. And naturally, the tiles are designed for rapid reuse with no refurbishment between flights. As we mentioned earlier, today's Starship features a completely reworked heat shield with stronger tiles and a secondary protective layer. This promises to increase our chances of Starship making it through a controlled re-entry and hopefully a little more intact this time around. And in between our first and second stages is our hot stage, which we last saw in action on flights 2, 3, and 4. Speaking of, let's take a trip back in time and talk about that last flight. On June 6th, Starship successfully lifted off at 7:50 a.m. Central Time from Starbase, Texas, cleared the launch tower, and went on to accomplish several major milestones and firsts. As you can see there, Super Heavy booster lifted off successfully and completed a full duration ascent burn. I love the view of the sound waves there. Following separation, Super Heavy booster successfully completed its flip maneuver, boost back burn as well to send it toward the splashdown zone, and it also jettisoned the hot stage adapter, as you can see there. We don't have to jettison that adapter in future iterations because it'll be a different design. Now, as you can see here, the booster is returning back to Earth using those hypersonic grid fins to steer it towards a precise landing in the Gulf of Mexico. The footage that we have coming up here, there it is from the buoy. I still remember seeing this on X for the first time, and it was so incredible to see that booster coming down, ending its flight with a soft splashdown 7 minutes and 24 seconds into the flight, and the crowd went wild.
And so did we. Starship's 6 second-stage Raptor engine successfully powered the vehicle to space and placed it on a trajectory that would re-enter less than 1 orbit later over the Indian Ocean. And following a coast phase in space, Starship re-entered the Earth's atmosphere, successfully making it through the phases of peak heating and max aerodynamic pressure, and demonstrating the ability to control the vehicle using its flaps while descending through the atmosphere at hypersonic speeds. And of course, Starlink on Starship once again enabled real-time telemetry and live high-definition video throughout every phase of entry, with external cameras providing views all the way to the flight's conclusion.
Flight 4 ended with Starship, with, again, the crowd going bonkers, with Starship igniting its 3 center Raptor engines and executing the first flip maneuver and landing burn that we had seen since our high-altitude campaign. And that was followed by a soft splashdown of the ship in the Indian Ocean 1 hour and 6 minutes later.
And we were all glued to the monitors watching the little flap that could the whole way down. Seeing the landing burn and splashdown was an incredible moment for the entire SpaceX team, and we'll be looking out for many more of these incredible moments today.
All right, so while today's mission profile is similar to Flight 4, we got a couple new test objectives, including catching the booster back at the launch tower.
In about 18 minutes from now, Super Heavy will ignite its 33 Raptor engines and lift off from Starbase. A little more than 2.5 minutes into flight, the Super Heavy booster will separate from the ship in a hot stage separation. After that separation, the booster will perform a flip maneuver followed by a boost back burn. And about 2 seconds after that burn ends, we'll jettison the booster's hot stage. As it heads back towards the ground, the booster will either attempt a landing, will have a landing burn, but then will either return to the tower or splashing down in the Gulf of Mexico.
Meanwhile, the ship's engines will remain lit for just under 6 minutes during its ascent phase before shutting down for the coast. The ship will coast for about 40 minutes or so, reaching a peak altitude of about 213 kilometers. After that coast phase, the ship will be attempting a controlled re-entry, including a flip maneuver and landing burn, like we saw on Flight 4, just before splashing down in the Indian Ocean. Now, we say attempting because, again, this is just a test and nothing is guaranteed.
Except excitement.
Well, of course there is that. Now, both the booster and ship have to contend with some extreme conditions on re-entry, which is where those heat shield tiles will be put to the test.
For this flight test, we do not expect to recover any hardware from the ship. With the exception of Falcon, this is no different than what happens to most rockets flying today that are expended, meaning that they fall into the ocean after completing their mission. Eventually, we will return and reuse Super Heavy boosters and Starships as we do today with Falcon 9 and Falcon Heavy boosters. And in fact, we've landed Falcon boosters 352 times to date.
Oh, man. I hear you say that number, and that is just wild. I still remember the night, or at least most of the night, that Falcon landed for the first time, and it still feels like yesterday.
Yeah, definitely one of my favorite moments at SpaceX. And returning Super Heavy promises to be an even more impressive sight and a huge moment on the road to rapid reusability.
Yeah, speaking of rapid reusability, future Starship designs will give Super Heavy boosters a lighter weight and integrated hot stage intended for full reusability, which will mitigate the need to jettison the hot stage like we'll do today. Similarly, even though ship recovery is not expected, the telemetry and data we receive all the way to the end is what we're what we're looking for, and is what will get us to a rapidly reusable Starship of the future.
Yeah, exactly. In other words, just like previous Starship flights, the payload for this mission is the data. All right. Now that we have a handle on today's flight test, let's check in with Dan, who is right in the middle of the action. He's just a few kilometers from Starship on the pad. How's it going, Dan?
It's going great, Jesse. Welcome back to Starbase, everybody. It's been far too long. Little change of scenery this time. Right behind me is the Launch Control Center, where our flight controllers are counting down to our liftoff at 7:25 a.m. Central. We are a little bit later in our window. The main reason is we're working to clear out the range. Have not been tracking any technical issues so far to preclude that launch. So 7:25 a.m. Central, 12:25 UTC is what we're marching down to. As you can see, we're actively loading propellants onboard Super Heavy and Starship. Liquid methane for your fuel, liquid oxygen for the oxidizer. Prop load on the ship started at about T-minus 49 minutes, booster at T-minus 40 minutes. We're going to keep loading propellants on those vehicles right down to the wire. Ship will close out at about 3 minutes and 20 seconds before T0, and then booster just about 30 seconds later. Now, with our startup sequence, it's going to look very similar to what you saw on Flight 4. We already tested it with this booster and its static fire. We're going to see the Raptors start to make fire at about T-minus 3 seconds, and then we'll start them up in 3 different banks. The first inner 13 will fire, and then about a second later, 15 of the outer ring engines, and then about 0.8 of a second after that, those final 5. Another reminder, if we need to hold, we have a built-in spot at T-minus 40 seconds. We can hold for stuff like if we need to finish clearing the range or if any other technical issues pop up, just kind of in the last second. But if there's nothing holding us back, we're going to go right past that and go down to 0. So, I mean, as of right now, we're just under 14 minutes away from liftoff, not working any technical issues. Range is expected to clear. We're just clearing out a few more boats. And as you can see, the weather is perfect. We had 100% go for launch from the weather officer, so that was pretty unprecedented and something we really like to hear. If we're not able to go today, since we are loading prop, it would likely be about 48 hours before our next attempt. But good thing we're going to launch today. Really looking forward to being able to turn around and see it this time. Counting down to 7:25 a.m. Central, and I'll see you guys in a couple of minutes. I'll send it back to you in Hawthorne.
Thanks, Dan. Now, one of the most exciting objectives for Flight 5 today is attempting to return the booster to the launch site that you see right there, and it will be caught by the tower. We refer to this simply as booster catch.
As you've heard us say, Starship and Super Heavy are designed to be rapidly reused, which is why we've developed a novel way of returning the vehicles that leverages the same hardware we use for stacking ahead of flight.
Right now, when we recover our Falcon boosters, they either return to a separate landing zone on land or to a drone ship in the ocean, both of which require time to transport the vehicle back to the launch site. In order for us to achieve truly rapid reusability, we need a quicker turnaround. And you can't get much faster than returning the launch vehicle right back to the launch site where it needs to be in order to launch again.
For today's booster catch attempt, while there are thousands of criteria that need to be met, there are 3 primary gates that will be in play. In order to proceed, automated checks have to indicate we have a healthy booster and a healthy tower, and the flight director must issue a manual command, which is informed by manual checks from the flight control team. If this command is not sent prior to the completion of the boost back burn, or if automated health checks show unacceptable conditions with Super Heavy or the tower, the booster will default to a trajectory that takes it to a landing burn and soft splashdown in the Gulf of Mexico.
Now, thinking to the future when we're operational, after a booster returns to the launch tower, it will be inspected and reloaded with propellants and then ready to launch another ship to orbit. For today's test, however, we're only going to attempt the catch, like Jesse said, if everything on the booster and tower checks out after launch. And of course, we will let you know as soon as we know if it's a go. And we're going to be listening very keenly for that call out. Now, as always, we accept no compromises when it comes to the safety of the public and our team. So to that end, the area all around the pad and the flight path are cleared well in advance.
Exactly. A lot of things have to go right in order to line up the booster catch. So don't be surprised if we don't attempt the catch today. Either way, today's flight will generate data that will continue to inform our future flights and help us get to that operational cadence.
Yeah. Oh, you can't forget what else it will generate.
Are you thinking what I'm thinking?
I mean, I was going to say a sonic boom.
Oh, I was going to say excitement, but that's a really good reminder.
Now, if we do make it to a catch attempt today, Super Heavy may generate a sonic boom upon its return. And that's basically a brief thunder-like noise that we hear when an aircraft or other object travels faster than the speed of sound. anyone that has been in the area for a Falcon 9 land landing in Florida or California, or even some space shuttle landings, may have heard one of these.
Generally, the only impact in those surrounding areas of a sonic boom is the brief noise, with variables like weather and distance impacting if or how the sonic boom is heard. Here's a brief look at how these sonic booms look and sound on Falcon.
I know a lot of people will be excited when they hear the sonic boom.
And these are going to provide quite a show because you're going to hear the sonic booms.
Booster landing leg deployed.
That sonic boom is great for us.
That thunderclap broke the sound barrier.
Side booster separation confirmed.
Just heard the 2 sonic booms here in the room.
Booster landing confirmed.
As our test flights continue, we plan to demonstrate ship-to-ship propellant transfer, which will be important in preparation for Starship taking astronauts to the moon as part of NASA's Artemis program. SpaceX will perform one uncrewed demonstration flight before NASA's Artemis 3 mission, which will be the first human surface expedition since 1972. Also, in preparation for missions to the moon and Mars, we're gaining tons of knowledge from our human spaceflight missions, including free flyer flights like our recent commercial astronaut mission, Polaris Dawn.
Polaris Dawn was the first of up to 3 missions in the Polaris program, which is demonstrating new technologies, conducting extensive research, and will culminate in a flight of Starship with humans on board.
After nearly 5 days in orbit, Dragon and the 4-person Polaris Dawn crew safely splashed down on September 15th off the coast of Florida, completing the first human spaceflight mission of the Polaris program. The Polaris Dawn crew performed some incredible firsts during their mission. Dragon and the crew reached 1,408.1 kilometers, the highest Earth orbit ever flown, and the farthest humans have been from our planet since the Apollo program.
The crew also performed the first ever commercial EVA, or extravehicular activity. And as you can see there, they were wearing the new EVA suits that we developed here in-house. This was an incredible moment to see Jared and then later Sarah emerge and perform this EVA with Earth behind. Now, in addition to this incredible spacewalk, they also conducted about 36 research studies and experiments from 31 partner institutions, including NASA. And in addition to all of that, they also tested Starlink laser-based communications in space. The data gathered from Polaris Dawn missions is invaluable, much like the data that we're going to see after today's flight test of Starship. So we're coming down to T-minus about 7 minutes. Let's check in with Dan.
Hey, thanks, Kate. So yeah, we're right at about 7 minutes away from launch. The main thing we are still working is that range clear. Again, we have to make sure boats, airspace, everything is cleared out of the way for our ascent corridor, basically the Gulf of Mexico, where we're launching through before we can actually launch. And so we're working on clearing out just a few more boats. We do have a window, remember. So if we end up holding at like a T-minus 40 seconds, we can hold for several minutes, allow those boats to get out of the way, and then we can launch. Our window is from 7 to 7:30 Central, so we don't have a huge amount of time today, but we do have some margin if we need to work with it to still get off the ground today. For now, though, we're coming up on finishing prop load on both vehicles. Header tanks are pretty much topped out on the ship. Those are going to be used for its landing burn. And again, we're going to be closing out all of the prop load at about T-minus 3 minutes, 20 seconds for the ship, and then just 30 seconds later for booster. One kind of cool thing to talk about, so the folks in launch control behind me, after liftoff, they're going to have some pretty special tasks today if we're going to go through with the catch. They're going to be doing some really detailed inspections just visually of all of the different tower systems, a lot of those things that we upgraded, just to make sure that we are in the right posture to actually proceed with the catch. So they'll be working kind of fast and furious behind the scenes to inform the flight director's manual command to send the booster back. So if we hear that command being sent, that's going to be just the roof's going to come off. That's going to be a really exciting moment. So otherwise, if we don't go today, as you guys talked about, there is a chance. And if we don't send the booster back, we'll do a landing burn and a splashdown in the Gulf. And then that's just another landing burn to gather more data, learn more lessons from, and then we'll come back and try the catch again on the next one. But as of right now, we're coming up on 5 minutes. There is a chance that we'll hold or extend into the end of our window, so don't be surprised if that ends up happening. But if those boats do get out of the way, we are just about 5 minutes away from launch. So I'll check back in just a moment, but back over to you, Kate and Jesse.
Thanks, Dan. Our rapid iterative development approach has been the basis for all of SpaceX's major innovative advancements, including Falcon, Dragon, and Starlink. Today, we're testing hardware and systems, and we need to know how they perform under the most extreme conditions. We'd much rather find the bugs now during testing than later on when there's more on the line. And to reiterate, while we do determine an acceptable level of technical risk on our vehicle and pad in order to learn as fast as possible, we accept no compromises when it comes to the safety of the public or our team. So that is to say, this is only the fifth of many future flight tests of Starship before it becomes fully operational.
You might remember the Starlink panels that are incorporated into Starship, and you can see them there on your screen, those rectangular panels on Starship's nose cone. Starlink brings us the epic views in space and on re-entry, and also helps deliver us the critical flight data engineers need to continue development. In addition to enabling our rapid iteration on Starship, Starlink is also enabling life-saving communication here on Earth. SpaceX is sending tens of thousands of Starlink kits in response to Hurricanes Helene and Milton, and providing free service through the end of the year to support recovery efforts. The Starlink team also worked with T-Mobile to activate our direct-to-cell satellites to provide basic texting on T-Mobile and emergency alerts for all phones and carriers of those in affected areas. If a phone connects to a Starlink satellite, it will have 1 to 2 bars of signal and show T-Mobile SpaceX in the network name. SpaceX's direct-to-cell constellation has not been fully deployed, so these services are being delivered on a best effort basis.
Starlink is enabling life-saving communication here on Earth and continues to help us push the limits in space. In the short term, by providing great views and real-time data on our next few flights, particularly through re-entry, which historically is a blackout period for all communications.
All right, so we're coming up on 2 minutes, 30 seconds away from launch. We were hearing like there was a pretty good chance we were going to hold at T-minus 40 seconds, but surprise, now it sounds like we might not be. So we are just a little over 2 minutes away, so a couple more things going to be happening. We did just close out our propellant load on the ship and the booster, so 10 million pounds of propellant on that vehicle on the pad here at Starbase, getting ready to go. We're going to start clearing out all of the lines that are basically pushing all of that propellant to the vehicles. Those get cleaned out or cleared out on the ground before we lift off. We're doing some final checks on the vehicle, the thrust vector control that we're going to use to steer it, as well as the guidance system doing its final alignment, just a lot of our final checkouts. But we are starting to hear that it looks like the range is going to be clear at our liftoff time of 7:25 a.m. Central, 12:25 UTC. So that puts us 1 minute, 20 seconds away from launch. Still not tracking any technical issues. That range clear is the only thing that's been potentially poking at our launch. So I'm going to start to quiet down. We'll hear our flight director for today, Tristan Pierce, give some of the final call-outs. As of right now, we are 1 minute away from liftoff.
Flight directors go for launch.
Best words you could possibly hear 20 seconds away from liftoff.
T-minus 5, 4, 3, 2, 1. We have liftoff.
Vehicles pitching downrange. Booster after chamber pressure nominal.
"30 seconds into the flight, the rumble's just starting to reach us here at launch control.
Booster and ship, avionics power and telemetry nominal.
33 Raptor engines.
Max Q.
Now pass through the maximum aerodynamic pressure, the most stress the vehicle's going to see on the way uphill. All right, our next major milestone coming up, it's going to be hot staging. We're going to see the engines ignite on ship to push it away from the booster. All right, so hot staging is going to be the next thing coming up. First, we're going to see the booster's engines start to shut down, all but 3. We're going to do what's called most engines cut off instead of main engine cut off, because 3 are going to keep going, and then we're going to see the engines on ship ignite. Right now, the tower team is doing their go, no go. And we might hear some really good words soon, too. All right. Can still see it up behind me. That is one of the most gorgeous things I've ever seen in my entire life. Coming up on hot staging next.
Ship engine
There's
startup.
most engines cut off.
Stage separation. Booster
Stage separation. Hot stage separation confirmed. Ship under its own power. I'm seeing 6 out of 6 Raptors lit. Hopefully I got a booster on the way back to me. I'm going to send it to you guys in Hawthorne.
Oh, man. That was absolutely incredible. I loved how the crowd...
Chamber pressure is nominal.
The crowd here in Hawthorne all went, ooh, at that first view of the blue flames from the booster. As you can see there, first stage currently performing, is now making its way back to the launch site. Again, we are...
Ship, avionics, power, and telemetry nominal.
The booster and the tower are both performing automated checks to make sure we are go for the booster to return to the launch pad for that catch. And once those are complete, the flight director...
Booster, boost back burn, shut down.
Flight directors go for booster return.
And we did hear that the tower is go for catch. So that was one of the big criteria we were looking for.
This view
We'll
here...
wait to hear that the go for catch has been sent.
Beautiful view here from the ship.
And so exciting to hear that we got a go for booster catch. That means it's going to be a really exciting morning. Again, the booster is making its way back towards now land in order to make that catch attempt in the tower.
So incredible to see these views. You can see the ship on the right-hand side of your screen. All 6 Raptor engines are under full power. Once again, the booster is making its way back to the launch site. We are going to try and catch it using the chopsticks on the launch tower, the exact same tower that it just launched from just, 5 minutes ago.
Yeah, and the booster...
Starship on nominal trajectory.
I can confirm the command was sent for the booster to come back.
That is incredible.
So I'm looking up right now. It's pretty much right overhead of us, and we can see it starting to come down.
I can't wait for us to hear the sonic boom through Dan's mic.
Right.
That is going to be incredible. It was so cool to hear the liftoff. And so once again, it's successful on-time liftoff of Starship Flight 5. The ship has separated from the booster. The booster is there on your screen. It is making its way back to the launch site. We are going to attempt the catch using the chopsticks. We did hear the confirmation that the command was sent to the tower. We are go for catch.
And in order to...
And guys, we should just be about 30 seconds away from our landing burn. It's going to happen in 3 phases. We're going to land 13 engines, burn off all of that velocity. Oh, we can see it coming down through the plume.
Booster coming in hot for booster catch.
We're going to ignite 13 of those Raptor engines, and this view is incredible right now. You can see how fast this vehicle is moving on the left-hand screen.
Landing burn has been ignited. We're now down to 3 Raptor engines. We can see those chopsticks now in the air.
Shutdown.
Megavilla has popped the booster.
This is absolutely insane. On the first ever attempt, we have successfully caught the Super Heavy booster back at the launch tower.
What an incredible view!
Are you kidding me?
Dan, wow. I don't know about you, but we're losing our stuff up here.
Guys, I'm sorry. Like, even in this day and age, what we just saw, that looked like magic. Wow.
Dan, your view must have been insane. We are still going wild over here over this.
Folks, this is a day for the engineering history books. This is a live view of the Super Heavy booster as it has just been successfully caught back at the very same launch tower that it just came from. Dan, I love this. You are reflecting exactly what everybody else here in Hawthorne, except maybe a little bit more because you got to see it with your own eyes.
How was that?
We got it. I mean, I can't even describe that. Oh, by the way, main engine cut off, ship's in orbit, but I am like shaking right now. That was...
Yeah, this is not,
yeah, let's
it's...
check in on ship.
It's hard to believe that...
Starship nominal orbit insertion.
All right, exciting news there. It's hard to believe that, booster isn't the only excitement that we have today. Just confirmation there. A gorgeous view of planet Earth behind the ship.
Saved.
And it is now in the orbit that we expected it to. This is just an incredible day. Live views there as the booster vents some pressures there. That is a live view from the top of the tower looking at the chopsticks.
I am still in disbelief. I'm trying to catch my tears just like the chopsticks caught the booster. It has been nonstop since liftoff. And we are all so excited about everything that's been happening so far this morning. With the booster having completed its job for today, we are going to take a short break for the next 30 minutes. We'll return back at T plus 40 minutes while the ship continues to coast before re-entry.
Oh, man. And as with previous flights, Starlink may actually enable us to talk with the ship through re-entry with no communication blackout. We, of course, are still testing Starlink during this phase of flight, so nothing is certain. But if we do have views, we'll be sure to bring those to you live.
Views or no views, we'll see you back here at T plus 40 minutes for coverage of Starship's re-entry, flip maneuver, landing burn, and splashdown. welcome back to Starship's 5th flight test. It has been an exciting day so far. Even the crowd here is still so excited. We lifted off from Starbase at 7:25 a.m. Central Time. The Super Heavy booster and ship had a successful separation, as well as a good boost back burn and good separation of the hot stage adapter. The Super Heavy booster then completed the landing burn with 13 Raptor engines igniting and slowing down the vehicle perfectly for Mechazilla to catch the Super Heavy booster for the first ever land recovery of the vehicle.
Now, it is insane to think that we're not done yet. We still have, in about 48 minutes, the ship will re-enter. The flap, all the flaps that will today, not that could. The ship will re-enter the Earth's atmosphere. Now, as a reminder, one of the main goals of today's test flight is for the ship to make it through the extreme heat of re-entry and to do so in a controlled manner. We learned a lot about this phase during Flight 4 and, as a result, completely reworked the heat shield, but more on all that in just a minute. Now, re-entry is typically a portion of flight where we don't have communications with the spacecraft because re-entering, it'll be re-entering at about 8 kilometers per second, or about 5 miles per second of roughly orbital velocity. Now, those speeds, the spacecraft moving through the atmosphere results in friction and creates a plasma field around the vehicle. We saw this in action on Flight 4 thanks to Starlink, and wow, it was breathtaking. The blanket of plasma ends up distorting communication frequencies, so it's not uncommon to experience brief blackouts in communication, but hopefully that's not the case today.
And Kate, that's where Starlink has just kind of been just the unsung hero and the MVP of this test campaign. I mean, it's able to give us data, not just awesome video, but also data in real time as we're going through reentry. I mean, this is something that throughout the history of spaceflight just hasn't been possible. And this is an environment that is so unforgiving, so hard to model, so hard to understand. And for the first time ever, we're able to literally watch as it unfolds in real time, get that data in real time. And we're able to do that with Starlink. And it's great for us because we get to see something. We get to see the greatest light show on the planet or off the planet. But what it means for this program, we're able to learn tremendous amounts about our heat shield, our angle of attack, everything that we're doing as we're coming in through the atmosphere at hypersonic speeds. And it's you can't just thank it enough. And also, special shout out, you're going to see some additional flap camera views. We've got a really amazing team of avionics, cameras, electronics, software people who made all that possible. And so hopefully they're going to give us an even better show on the way in today as we're coming in at about 5 times the speed of sound.
Yeah, those flaps, Dan, that you see there, that's what's helping.
Starship is in a good attitude for entry, approaching the entry interface.
Some good call-outs there, preparing for re-entry for Starship. And again, that's what Dan was mentioning, those flaps on the vehicle. And if you've been watching us for the last few minutes, you could see that the flaps were rotating around and helping orient the vehicle as it prepares for the beginning of re-entry today.
Yeah, exactly. Re-entry will be enabled by that heat shield that you see on the bottom half. That heat shield is made up of 18,000 hexagonal ceramic tiles, and they are designed to insulate the vehicle during atmospheric entry. At that point in time, temperatures can be as high as 26,000 degrees Fahrenheit or about 1,400 degrees Celsius. The design itself also permits for rapid reuse with no refurbishment between the flights. And fun fact that I think is just incredible in terms of scale, but the heat shield alone on the ship has a total mass of 10.5 tons, which is crazy because these things are really lightweight. They're made out of ceramic. We have a couple of them here. The one that I'm holding is used on flat surfaces, as let's see if we go that way, because as it's flat. The one that Jesse has is kind of more what you see there on the side.
Yeah, exactly. And having these different shapes, the flat version and the curved version, allow us to cover a lot more of the surface area of the vehicle. Again, we need to protect every portion of it. So even those curved surfaces, and especially the hinge area, if you watched Flight 4, is really what we want to make sure that we protect. And yeah, Kate, these are very, very lightweight.
But when you put 18,000 of them together, they add up to 10.5 tons, which is incredible. Now, we did mention earlier that the heat shield has been completely reworked.
Starship has entered the atmosphere, remains on a nominal entry trajectory.
We can start to see that plasma now starting to build up on the side. It's not quite full plasma yet, but we are starting to see that color indicate that the heat is building up on the heat shield.
Yeah, this is such a cool sight to see because you really never really have gotten to see this live before Flight
4.
Yeah. And as Kate mentioned, it's getting a little more red, as you can see there on your screen. That means that heat is building up. But that's exactly what these heat shield tiles are there for, is to protect against this plasma and this really, really extreme heat that the vehicle is going to see for about the next 10 more minutes or so.
Yeah, so the ship will attempt to light the 3 center Raptor engines, and those are the engines that can gimbal or maneuver or point, and they do that to help flip the ship until the engines point down so that it can land using the Raptor's thrust in the ocean. So that will happen after we get through this re-entry period. Again, now starting to see, and we also might start to see the flaps actuate a little bit here as the vehicle controls its roll during re-entry. That was one of the main learning points from Flight 3, was the roll control didn't work quite as well as we wanted it to. We learned that we needed some redundancies, so we added more roll control thrusters, and we'll see those in action as well today, as that was a Flight 3 learning that worked better on Flight 4 and still enabling that same design today.
Yeah.
Starship has passed through 85 kilometers altitude. Flaps now have control of the vehicle.
Great call out, as Kate mentioned, the flaps are controlling the attitude of the vehicle. And I love these views because it looks so calm. Everything is relative, right? So relative to this camera on the ship, it looks so calm and smooth, but the vehicle is traveling extremely fast. You can see the speed on the bottom right-hand corner of your screen. Starship is designed to land on Mars, where there are no runways or other humans to help out. So we also want rapid reusability. So we're doing propulsive landing instead of a more traditional means like parachutes. And so we will use the engines on this vehicle to help slow the vehicle down for a vertical landing.
Yeah. Now, entry is going to basically happen in 5 phases. The first is low drag, that lasts for about 3 minutes. Next is high heating, and beginning when heating increases above the heat rate breakup limit. That lasts for about 10 minutes. We then have high dynamic pressure. Starship will continue to slow down and experience increased aerodynamic loads during that phase, and that will happen before reaching Mach 1, about a minute after.
Starship is approaching the peak heating phase of entry, remains on a nominal trajectory.
Okay, so that was phase 2 that he just called out, that I was mentioning. After peak heating is that dynamic pressure around Mach 1, and that will last about a minute after leaving the hypersonic area, and then we go into subsonic, and then, of course, landing burn. Wow, what an incredible view.
The colors are so amazing, and the colors actually also tell you a little bit about the temperature that the vehicle is seeing as well. So I think that's pretty cool that we get this amazing live visual.
Speaking of live visual, the flap, we have more views, more cameras on board Starship, as Dan mentioned a few minutes ago. We are hoping that all 4 flaps will stay more intact than they did last time. We did make some changes to the design in order to help enable
Starship
this.
is now experiencing peak heating, remains on a nominal entry trajectory.
Great news there. that Starship is continuing along the path that we intended it to fly. You can keep track with how fast it's going and how high it is above Earth using the display that is there on the bottom right-hand side of your screen.
And guys, this is where we're really going to see a lot of those improvements from Flight 4 really come into action. Is you guys kind of talked about, so it's called the static arrow. Those are kind of the poke out points on the flaps. Those get exposed to some pretty extreme heat environments, and so we added some additional, basically made it a lot more robust for the thermal protection there. And we learned not just from visuals and stuff like that. We had those missing tile tests on Flight 4 where we intentionally left some out, kept in some backup layers. They're called ablatives, which means they just gradually melt away to help dissipate the heat. And we've got an entire layer of ablative underneath the tiles on this Starship today. So even if you get a gap in a tile or a tile is broken, anything like that, we've got essentially backup options. And what we're really trying to do today is do an on-target landing. As we lost the flaps, you lose a lot of your control, and so we didn't land right on target last flight. This time we're trying to really nail the target within just tens of meters, and that'll just be a really huge step on feeling like we're closer to bringing a ship back. Obviously, there's a lot of work before we get there, but we just caught a booster. We're going to start looking real soon at when we can catch a ship.
So the view on your left is as a helicopter passes by Dan, bound at Starbase. The view on your left is a camera that's positioned near the nose of the ship, looking basically down toward the flap. The view on the right is looking perpendicular to the flap. So we're looking basically bird's eye view onto the flap on the left-hand side, and then a worm's eye view from the side with that view on the right.
Yeah, sorry about that, guys. Maverick just buzzed the tower. He might be coming back, so.
Now, these views brought to us by Starlink. It's incredible that we have this high-definition capability. In fact, that view on the left...
Starship is now halfway through the peak heating phase of entry, remains on a good trajectory.
So great news there, hearing that we're about halfway through the peak heating phase. Like I said earlier, this lasts roughly 10-ish minutes. And we did hear earlier that the flaps have control of the vehicle, so also good news there. It is incredible that we've basically had views the entire time.
Right, yeah, thanks to Starlink.
My memory did black out a little bit after booster catch, so I think we had views. But, all through the coast phase, we had some beautiful views of planet Earth behind the ship as it was in its orbit.
Yeah, and I also do want to point out on your right-hand screen, we've got a more encompassed view of the flap. As we watched in Flight 4, the hinge area was the area where we got a little bit of that burn through. This view, this new camera view on the ship, will help us be able to visually see more of what's happening in that area. And again, we have improved our heating tiles, and so hopefully we've protected the hinge a lot better this time.
Chill has started.
But again, these views are additional to the data that we get on these flight tests that help enable us kind of put the data that we get in the computer to the visuals that we see and try and align those and use that for improvements in the future.
Now, we heard a call out there saying that engine chill has begun. This is an indication that we are starting to flow a little bit of the super cold liquid oxygen through the hardware, through the Raptor engine, specifically the turbo pumps, to help ensure that the hardware is at the right temperature before we give a full push, a full flow of propellant at engine startup. So all of that to say, we are getting closer to the landing burn.
We definitely are. And again, if you look at the bottom right hand of your screen, you can see the altitude that the ship is, and it has been slowly making its way closer and closer to Earth. We're currently at about 63 kilometers from planet Earth, and you'll see that number trend lower and lower as we get closer and continue through this reentry.
Yeah, this is going to go on for a little, actually a while longer. We have about 10 minutes or so, roughly, before we execute the landing, the ignition for the landing burn, starting with the landing flip. So we're making a controlled reentry. This is one of the primary objectives for Starship today, is to demonstrate another controlled reentry, even more controlled than what we saw on Flight 4. And so far, that is looking good.
And then as we start to really get lower, we're going to start seeing the atmosphere's effects start to take place, and that's when we'll be dropping our speed down closer to the speed of sound. You'll see the flaps start to maneuver. We were able to do a landing burn on Flight 4, which kind of caught all of us off guard. It was pretty incredible after seeing the flaps survive through. And we're going to try and do another one on this flight today. We tweaked it a little bit, so we're going to try and splash down at a little bit of a gentler angle this time, instead of just kind of hit the water and fall over. And the goal with that is try and keep the ship intact, and then if we're able to then get some additional video of it, again, that's just more data. And everything we can see, everything we can get extra, like a couple extra seconds or minutes of data coming from the ship after
Starship has
splashdown.
passed through the peak heating phase of flight, approaching maximum entry dynamic pressure.
All right, we're through peak heating. Coming up is basically max Q part 2, where we're going to hit kind of that part of the curve where we're still moving really fast and the atmosphere is just dense enough that we're feeling the most pressure, but hopefully we're going to start feeling a little bit less heat now.
Looks like we got more views of each of the flaps on the ship as it's making its way back down to Earth. And we did pass through peak heating and still got really good views throughout that whole period. Typically during the highest heat on the vehicle, we tend to build up a lot of plasma, and that's typically when we would lose connection or views of the vehicle. But again, with Starlink, we were able to get some live views throughout that entire process there.
And we're coming up, we'll start hearing a couple more milestones in about 4 minutes or so, when we start getting down to like the transonic, the subsonic, when we're starting to move closer to and beneath the speed of sound. And I mean, we're getting live views, we're getting live data. We've got a couple additional tests on this one today where we left off some missing tiles again to test some additional backup layers. We also have, I don't know if we can still quite see them in this view, but you may have noticed we had some kind of silvery looking tiles on Starship as well. And those were pretty much standard tiles, but they were wrapped in aluminum. And it was a pretty simplistic, straightforward one where aluminum starts to melt at roughly the same temperature where steel starts to lose its strength, not necessarily melt. And so if we see stuff melting, we know what our steel is going to be exposed to. But yeah, 59 minutes since launch, should be coming up on transonic and everything in just about 3 minutes.
Now the views here, we have coverage of all 4 flaps. We can see, so for those that perhaps didn't catch a glimpse of the vehicle before liftoff, there are 2 flaps at the forward end and 2 flaps at the aft end. The larger camera view that is there on the right-hand side of your screen, that is a view of one of the aft end or the bottom end flaps. We can start to see some heat buildup and peeking through on one of the flaps there in the top left-hand corner of your screen. Once again, Starship now at T+1 hour and 9 seconds into its flight today, re-entering the Earth's atmosphere. Currently about 45 kilometers above the surface of the Earth, now 44. We are targeting a soft splashdown in the Indian Ocean, about, northwest-ish of Australia. And we are attempting to, as we did on Flight 4, perform a flip maneuver as well as
Starship is at maximum entry dynamic pressure, remains on a good trajectory.
All right, so that is great news there. Like Dan said earlier, this is basically max Q part 2. So this is the greatest amount of aerodynamic loads that the vehicle will experience during its flight. It's coming back through the Earth's atmosphere. It was above the Earth's atmosphere in space where there was no friction. We can obviously see heat as evidence of that friction buildup. The atmosphere is actually helping to slow the vehicle down. If you're watching the telemetry in the bottom right-hand corner of your screen, you can see that speed decelerating rapidly. Now, the 4 flaps on the ship help steer the vehicle, and one of the main objectives for the ship today is to demonstrate controlled re-entry during this phase of flight, this re-entry phase.
Yeah, and we have 6 engines on ship, but we only need 3 of them, the 3 sea-level engines. We will have that flip maneuver happen very close to touching down for splashdown. We'll do that flip maneuver, ignite those engines, slow the vehicle down immediately, and then hopefully have what we call a soft splashdown in the water. It's probably going to feel a little bit harder on the top of the surface of the water, but it'll look pretty gentle.
Yeah, and like we said earlier, we hope to have some more views, even of that phase of the flight. So fingers crossed that we can we can bring those to you. We are hoping to splash down softer than we did last time on Flight 4. Right now, Starship continuing to make its descent back to planet Earth.
Starship is at Mach 2, remains on a good trajectory.
All right, great news there. That tells us that the vehicle is traveling twice the speed of sound. So we will then, the next call out that we'll hear is that it is, traveling about the speed of sound. And then we will hear a call out that that will be the call out that it is transonic. And then we will hear another call out saying that it is subsonic, meaning going slower than the speed of sound.
Starship is transonic.
There it is. So at this point in time, we say transonic because certain parts of the vehicle, like the flap that you see on your screen, might be experiencing airflow faster than the speed of sound, while other parts of the ship may be experiencing airflow.
Starship is in the subsonic belly flop.
All right, so now the entire vehicle is traveling slower than the speed of sound, so subsonic. The crowd here at Mission Control Hawthorne also getting excited, just like us. We're awaiting a water landing. We are going to reignite the 3 engines to perform that flip maneuver, and we're basically about a minute and a half, away from the landing flip.
Yeah, the crowd's getting excited here as we get closer and closer to splashdown. Again, just about a minute away from the expected splashdown, so we should see a lot happening coming up here shortly. We're currently having a view of one of the flaps, and it is a little bit dark on your screen, but hopefully we'll get some good views of the ship as it makes that flip maneuver and touchdown for splashdown.
Yeah,
yeah, guys, we saw that speed drop like a rock. So we're doing a belly flip right now, or a belly flop right now. That's what's kind of, if you saw the high altitude campaign, that's the unique thing about how Starship comes back. So we've bled off pretty much all of the speed we're going to. We're essentially at terminal velocity.
Starship is at 5 kilometers altitude, remains on target.
Five to go, coming up soon, landing burn.
Two kilometers away.
Starship is on target, approaching landing burn startup.
So keep an eye on the bottom right-hand side of your screen as well. That will be the indicator when the Raptor engines ignite, if we are unable to see that illumination ourselves.
Landing burn startup.
What a cool view of the reflection of that landing burn.
We can see the water just behind the ship.
Starship has landed.
An incredible view. I think it is safe to say we have a ship in the water.
Touchdown!
That is a live view from the ocean surface. What an incredible end to Starship's journey. A live view from a buoy that we had out at the landing zone.
An incredible view of ship landing just about on target as they were calling out.
That was amazing. And we were not intending to recover any of the ship's hardware, so that was the best ending that we could have hoped for.
Man, I don't think we're going to be able to get a ton of extra video of the heat shield, but we hit the target. We hit the target. Yeah. I mean, we hit the target because we had these buoys placed in a pretty specific spot, so wow. What a day. I feel like that's what I get to say. What a day. I mean, everything started off today with that launch. We were able to lift off towards the end of our window, 7:25 a.m. Central Time. 33 out of 33 Raptors in the way uphill. Successful hot stage. Booster came back. We watched it come down right behind us. Watched it get caught. And that broke my brain for a while. I'm really happy we had coast for a bit, but that's first ever booster catch, major step on the way to rapid reusability. And ship just gave us one heck of a show, making it through a controlled re-entry this time, flaps intact, made it down to the water. Hey, starships were meant to fly, and it sure as hell flew today. So let's get ready for the next one. Over to you guys.
They were meant to fly, and they were also meant to be caught by Mechazilla.
Yeah.
It's been such an incredible day today. Congratulations to our teammates and to everyone who supported the Starship program. And thank you to all of our future customers for your support. And we'll also like to thank the people of Cameron County, Texas, as well as the Coast Guard, the Federal Aviation Administration, the Government of Mexico, and the Australian Space Agency.
Now be sure to follow SpaceX on X for more updates on today's test flight and, of course, for future Starship news. Today was amazing, but the SpaceX action isn't over yet. Soon Falcon Heavy will launch NASA's Europa Clipper, and we're also going to be returning Dragon back to Earth with NASA's Crew 8 astronauts. So congratulations again to the SpaceX team. What an amazing launch and an even cooler catch. Thank you for watching, but we're going to leave you with an awesome recap of what has been the most epic day.
sobre el Falcon 9, chicos? ¿O no? Bueno, por si acaso lo vamos a hablar después. Ahora nos tocaría el Dragon. Estamos a 1 hora del despegue de la Starship. El Dragon, el que va a llevar a los humanos, bueno, el que está llevando a los humanos al espacio, se han hecho 55 misiones, 50 visitas a la Estación Espacial Internacional y 35... Acá tenemos un modelo. 8,1 metros, el 26,7 pies, diámetro 4 metros o 13 pies. El volumen de la spacecraft 9,3, 3,28 pies. El tronco de volumen 37 metros, 1300 pies. Ya acá está la masa y eso. No lo pienso decir porque son cantidades grandes, así que no las pienso decir. Trato de no darme tanto. El Draco. No sé qué es lo que hace. Ah, ya. Y esto es lo que va a llevar. Esto es lo que lleva personas acá. Este es el dragón por dentro. Y acá, bueno, seguimos viendo. Por tiempo tenemos que ver cosas como el Falcon 9 por si acaso y el Mars Begoint y la Starship. Bueno, comenzaremos a ver el Falcon 9 por mientras. El Falcon 9, el primer orbital tipo de clase cohete reutilizable. 638 misiones completadas. ¿Qué era la landing? Aterrizajes. Y reflex, reutilizar es lo más probable, ¿cierto? No, pues, no tendría sentido total de vuelos. Bueno, total. Vamos a ver el Falcon 9 Overview. 70 metros. No, si lo vimos. Ya. Vamos al tiro a Mars y Begoint. Como ya saben, el plan de Elon Musk es llegar a Marte y establecer ciudades. Mira, niñas ahí. Ejemplo. Y instalar. Los encargados van a ser la Starship. Y bueno, ¿qué es Marte? Un planeta que va a pasar su distancia y lo que dura un día. Fuerza gravitacional, 38% de la Tierra. Y eso. Meses que tarda en llegar a Marte son 6. Tiene 2 lunas Marte y tiene 14 satélites orbitando. La Starship es la spacecraft, el Super Heavy cohete que se va a encargar de enviar a los humanos a Marte. Este cohete que se va a lanzar hoy día. Y el encargado de llevar humanos a la Luna también. Mira, este es un multiplanetario. Van a hacer misiones a Marte, como le enseñamos que van a hacer con ascensores y eso. Y bueno, esto es lo que se usa. Y ahora nos vamos a preparar para la última parte de el último vehículo, la Starship. Voy a silenciar un poco el micrófono. Esperen, no les mostré el... Bueno, ahora les voy a hacer un resumen de lo que habíamos visto de Mars y Begoint. Después. Esta es la Starship. El overview, para los que quieren ver. Mira. Mide 124 metros o 407 pies. Diámetro 9 metros. Eso. Casi lo mismo que mide el Orion. Más de 100 toneladas puede llevar. Esta es la parte de la Starship. Y ahora vamos con el Super Heavy, que es la parte donde tiene los 33 motores. Y el Raptor, el motor super potente de SpaceX. El Starship no puede ser y llegar en cualquier plataforma de lanzamiento como el Artemis 2. Si no, se necesita la Starbase, esta parte de acá donde se lanza. Porque la Starship una vez dejó un hoyo incluso con hormigón. Por eso. Y ahora vamos con lo de Marte. En Marte y más allá. ciudad en Marte. Acá sale un plan, así como supuestamente van a ser las ciudades en Marte. ¿Qué es Marte? Esto tiene todo esto. Y acá sale un poco de las especies multiplanetarias. Construir ciudades en Marte. Lo más probable es que en unos futuros vamos a ver gente viviendo en Marte personalmente y no misiones científicas como lo que creemos. Como si fuera nuestra Tierra 2.0. Bueno, y eso es que tenemos por ahora. Nos vemos en un poquito más tarde en unos minutitos para ver el lanzamiento de la Starship. Muchas gracias por escuchar un poquito de nuestras presentaciones. Muchas gracias. 50 minutos para el despliegue de la Starship, probablemente. Cinco horas de transmisión llevamos. Gracias por quedarse.
Welcome back to Starship's 5th flight test. It has been an exciting day so far. Even the crowd here is still so excited. We lifted off from Starbase at 7:25 a.m. Central Time. The Super Heavy booster and ship had a successful separation as well as a good boost back burn and good separation of the hot stage adapter. The Super Heavy booster then completed the landing burn with 13 Raptor engines igniting and slowing down the vehicle perfectly for Mechazilla to catch the Super Heavy booster for the first ever land recovery of the vehicle.
Now, it is insane to think that we're not done yet. We still have, in about 48 minutes, the ship will re-enter. All the flaps that will today, not that could. The ship will re-enter the Earth's atmosphere. Now, as a reminder, one of the main goals of today's test flight is for the ship to make it through the extreme heat of re-entry and to do so in a controlled manner. We learned a lot about this phase during Flight 4 and, as a result, completely reworked the heat shield, but more on all that in just a minute. Now, re-entry is typically a portion of flight where we don't have communications with the spacecraft because re-entering, it'll be re-entering at about 8 kilometers per second, or about 5 miles per second of roughly orbital velocity. Now, those speeds, the spacecraft moving through the atmosphere results in friction and creates a plasma field around the vehicle. We saw this in action on Flight 4 thanks to Starlink, and wow, it was breathtaking. The blanket of plasma ends up distorting communication frequencies, so it's not uncommon to experience brief blackouts in communication, but hopefully that's not the case today.
And Kate, that's where Starlink has just kind of been just the unsung hero and the MVP of this test campaign. I mean, it's able to give us data, not just awesome video, but also data in real time as we're going through reentry. I mean, this is something that throughout the history of spaceflight just hasn't been possible. And this is an environment that is so unforgiving, so hard to model, so hard to understand. And for the first time ever, we're able to literally watch as it unfolds in real time, get that data in real time. And we're able to do that with Starlink. And it's great for us because we get to see something. We get to see the greatest light show on the planet or off the planet. But what it means for this program, we're able to learn tremendous amounts about our heat shield, our angle of attack, everything that we're doing as we're coming in through the atmosphere at hypersonic speeds. And it's, you can't just thank it enough. And also special shout out, you're going to see some additional flap camera views. We've got a really amazing team of avionics, cameras, electronics, software people who made all that possible. And so hopefully they're going to give us an even better show on the way in today as we're coming in at about 5 times the speed of sound.
Yeah, those flaps, Dan, that you see there, that's what's helping.
Starship is in a good attitude for entry, approaching the entry interface.
And some good call-outs there, preparing for re-entry for Starship. And again, that's what Dan was mentioning, those flaps on the vehicle. And if you've been watching us for the last few minutes, you could see that the flaps were rotating around and helping orient the vehicle as it prepares for the beginning of re-entry today.
Yeah, exactly. Re-entry will be enabled by that heat shield that you see on the bottom half. That heat shield is made up of 18,000 hexagonal ceramic tiles, and they are designed to insulate the vehicle during atmospheric entry. At that point in time, temperatures can be as high as 26,000 degrees Fahrenheit or about 1,400 degrees Celsius. The design itself also permits for rapid reuse with no refurbishment between the flights. And fun fact that I think is just incredible in terms of scale, but the heat shield alone on the ship has a total mass of 10.5 tons, which is crazy because these things are really lightweight. They're made out of ceramic. We have a couple of them here. The one that I'm holding is used on flat surfaces, as let's see if we go that way, because as it's flat. The one that Jesse has is kind of more what you see there on the side.
Yeah, exactly. And having these different shapes, the flat version and the curved version, allow us to cover a lot more of the surface area of the vehicle. Again, we need to protect every portion of it, so even those curved surfaces, and especially the hinge area, if you watched Flight 4, is really what we want to make sure that we protect. And yeah, Kate, these are very, very lightweight.
But when you put 18,000 of them together, they add up to 10.5 tons, which is incredible. Now, we did mention earlier that the heat shield has been completely reworked.
Starship has entered the atmosphere, remains on a nominal entry trajectory.
We can start to see that plasma now starting to build up on the side. It's not quite full plasma yet, but we are starting to see that color indicate that the heat is building up on the heat shield.
Yeah, this is such a cool sight to see because you really never really have gotten to see this live before Flight
4.
Yeah. And as Kate mentioned, it's getting a little more red, as you can see there on your screen. That means that heat is building up. But that's exactly what these heat shield tiles are there for, is to protect against this plasma and this really, really extreme heat that the vehicle is going to see for about the next 10 more minutes or so.
Yeah, so the ship will attempt to light the 3 center Raptor engines, and those are the engines that can gimbal or maneuver or point, and they do that to help flip the ship until the engines point down so that it can land using the Raptor's thrust in the ocean. So that will happen after we get through this re-entry period. Again, now starting to see, and we also might start to see the flaps actuate a little bit here as the vehicle controls its roll during re-entry. That was one of the main learning points from Flight 3, was the roll control didn't work quite as well as we wanted it to. We learned that we needed some redundancies, so we added more roll control thrusters, and we'll see those in action as well today, as that was a Flight 3 learning that worked better on Flight 4 and still enabling that same design today.
Yeah.
Starship has passed through 85 kilometers altitude. Flaps now have control of the vehicle.
Great call out, as Kate mentioned, the flaps are controlling the attitude of the vehicle. And I love these views because it looks so calm. Everything is relative, right? So relative to this camera on the ship, it looks so calm and smooth, but the vehicle is traveling extremely fast. You can see the speed on the bottom right-hand corner of your screen. Starship is designed to land on Mars where there are no runways or other humans to help out. So we also want rapid reusability. So we're doing propulsive landing instead of a more traditional means like parachutes. And so we will use the engines on this vehicle to help slow the vehicle down for a vertical landing.
Yeah. Now, entry is going to basically happen in 5 phases. The first is low drag, that lasts for about 3 minutes. Next is high heating, and that beginning when heating increases above the heat rate breakup limit. That lasts for about 10 minutes. We then have high dynamic pressure. Starship will continue to slow down and experience increased aerodynamic loads during that phase, and that will happen before reaching Mach 1, about a minute after.
Starship is approaching the peak heating phase of entry, remains on a nominal trajectory.
Okay, so that was phase 2 that he just called out, that I was mentioning. After peak heating is that dynamic pressure around Mach 1, and that will last about a minute after leaving the hypersonic area, and then we go into subsonic, and then, of course, landing burn. Wow, what an incredible view.
The colors are so amazing, and the colors actually also tell you a little bit about the temperature that the vehicle is seeing as well. So I think that's pretty cool that we get this amazing live visual.
Speaking of live visual, the flap, we have more views, more cameras on board Starship, as Dan mentioned a few minutes ago. We are hoping that all 4 flaps will stay more intact than they did last time. We did make some changes to the design in order to help enable
Starship
this.
is now experiencing peak heating, remains on a nominal entry trajectory.
Great news there. that Starship is continuing along the path that we intended it to fly. You can keep.
Estamos a poco para el lanzamiento de la Starship y comenzar a ver el directo, así que mira que ustedes me preparo.
They just gradually melt away to help dissipate.
Ok, nos vamos preparando un poquitito. Podemos esperar que inicie el broadcast por Twitter o por SpaceX, pero primero vamos a comenzar viéndolo por Twitter y después vamos a seguir viéndolo por SpaceX. Llevamos 5 horas de transmisión y bueno, no sé qué podemos hacer ahora mismo, pero nos podemos estar preparando para el lanzamiento de la Starship B3 y bueno, ya recuerden que ayer la Starship se estaba preparando para su lanzamiento, pero hubo unos problemas técnicos como siempre, y bueno, eso fue lo que ocurrió, que se canceló el vuelo y fue para hoy día. Ahora dejen, se escucha el audio, ¿cierto? Déjenme verificar si se escucha el audio. Bueno, ya. Sigamos, ya pude ver si se escucha el audio. Estamos esperando un poco la transmisión en vivo por Twitter. El Twitter. Que por culpa de Elon Musk todo se fue a la basura. Le cambiaron el nombre a X. Pero ya mínimo tenemos inteligencia artificial. Y bueno, voy a disfrutar después mi recompensa en Forsaken por 1 hora. Lo que me sorprende es que aún no inicia el broadcast y ya son como las 6 acá en mi país. Y bueno, la Starship hoy día se lanza, así que tenemos miles de cosas. Ahora mismo nos estamos preparando para que inicie el broadcast, el vuelo 12 de prueba de la Starship, donde hoy día va a debutar la nueva versión. Recuerden que pueden ver esto también en Kik, en el famosísimo Kik. Bueno, ahora esperemos un poquitito. Recuerden que si Starship se retrasa de nuevo, hay más probabilidades que la NASA contrate en vez de SpaceX a Blue Origin, que... espera. Acá está una parte de Blue Origin. Blue Origin, su idea es tener cohetes así. Es como algo parecido a sus cápsulas. Lo que hace es que el objetivo es crear cohetes reutilizables, igual que SpaceX, y también como el New Glenn. Este cohete hace unas semanas explotó. Bueno, más bien dicho, falló. Recuerden que también está la versión New Shepard. Ya se abrió el broadcast. Como que están teniendo problemas los de SpaceX. Ya inició acá en Kik, acá en Twitter. Ok, recuerden que la Starship tiene 33 motores en el Super Heavy. Y recuerden que esto no se lanza en cualquier plataforma de lanzamiento. Se lanza en la Starbase. Esa cosa que ven ahí es la plataforma de lanzamiento de Starbase, donde una vez se atrapó el propulsor, fue en una de esas Starbase que tienen. Llevamos 5 horas de transmisión con 40 minutos. Recuerden que quedan 26 minutos para el despliegue. Vamos a quitar el timer, lo vamos a mover para acá. Si acá sale el total, ¿cuándo va a ser? La Starship está como más de 124 metros aprox. Yo estoy monitoreando todo por... Hoy no hay configuraciones para ponerle subtítulos. Siempre se suelen transmitir primero en... Acá está, ya. Acá lo estamos viendo. Recuerden... Ay, mejor lo vemos por Twitter. Mejor por Twitter. Ya. Se me está medio bugueando. Voy a tratar de... Lamentablemente se me bugueó. Lo siento, amigos. Si se preguntan dónde lo pueden ver, se puede ver esto por X. El humo blanco que se está viendo actualmente se causa por el aire condensado por el oxígeno líquido y el hidrógeno líquido, ya que están a bajas temperaturas. Causa esto. Recuerden que esto, si se aborta la misión, lamentablemente tendrán que contratar a Blue Origin por tantos retrasos. Estoy viendo porque necesito tener harta vista y en SpaceX se puede ver mejor. Ya. Estamos a poco tiempo del lanzamiento de la Starship. Tenemos en SpaceX tenemos 143 viewers, o no sé si en X, no sé cómo, pero voy a buscar un poco más de personas reaccionando. Y bueno, estoy preparándome un poco porque este es un momento especial para mí. Ustedes saben que... miren, ¿cómo lo explico? Ustedes ¿Cómo le explico? A mí me gusta harto la astronomía. Quiero ser astronauta y eso, pero no quiero tratar de hacerlo, pero no puedo hacerlo por ahora. Pero les juro que un día voy a terminar en el espacio. Yo no tengo ni astrofobia, yo soy amante del espacio. De hecho, quiero hacer mi canal. Mi canal más como de astronomía y eso. Aunque no significa que no voy a subir más cosas como de juegos y eso, también voy a seguir. También a mí me carga que digan, es que el alunizaje fue falso, que fuimos al espacio. Mira. A mí me carga muchísimo. Es como si maltrataran a tu amigo. A tu amigo de toda la vida. ¿Qué harías? Defender lo que yo lo defendería, por eso. También esa película de Copán, la leyenda, fue la que más me cargó por decir que el alunizaje fue falso y eso. Y también yo veo harto sobre cohetes espaciales y eso. Y también veo no solamente eso, también veo tecnología y también juegos. Por ejemplo, he visto juegos como Kerbal Space Program. También me vi el Game Overs, la nueva serie de Glitch. Y estuve también jugando Minecraft. De hecho, ¿qué podríamos hacer? Podríamos crear un juego. Estoy creando un juego. Y mira, un juego de código abierto del espacio. Estoy creando unos modelos con IA, obviamente, porque no quiero modelar parte por parte. Y bueno, también me sé la evolución de SpaceX varias veces. Y también me vi el despliegue del Artemis 2 de la RS-34 misión de SpaceX. Voy a silenciar un ratito el micrófono. Ok, ahora comenzó a salir harto humo blanco. Porque el humo blanco, ya les expliqué que es aire condensado y tiene que haber expulsión para el gas. Porque si no el cohete hace kaboom. Por eso. También me voy a poner a escuchar un poco el directo. También la idea de la Starship es como repostar combustible dentro del espacio. Algo que igual va a ser difícil porque como vas a tener, como en el espacio hay menos gravedad. No hay, te mintieron que no hay gravedad. Sí hay gravedad en el espacio. Sante que es menor la gravedad. Hoy día también en la Starship se estrenan los nuevos motores Raptors, los Raptors V3. Estos cohetes de Starship van a ser los que nos lleven a Marte y a la Luna de vuelta. Y no para ir a poner una bandera y ya, sino vamos a hacer algo mejor, vivir allá. Cuando bajen los alquileres en la Luna, ahí voy a estar ahí alquilando una casa en la Luna. Acá estamos viendo un poco de ingeniería de SpaceX. Aún no cacho qué es lo que es. Pero también afuera, un poquito más allá, vi una parte de interetapa, creo. Esa parte de ahí ya no se ve. También recuerden que SpaceX está contratada por la NASA. Y SpaceX ha hecho igual logros bien grandes, como atrapar el propulsor y crear cohetes reusables. Por ejemplo, la Starship es 100% reutilizable. Y bueno, espera, atrás se me ve el multimedia. Ya. También lo que podríamos comenzar a ver y bueno, lo que también recuerda que las naves tienen que hacer una maniobra interplanetaria o algo parecido, que es como avanzar. No sé si han jugado Kerbal Space Program o Space Flight Simulator, pero sale un anillo y va a ser la trayectoria de ese anillo, y dependiendo de cómo vayas, así va a ser. Por ejemplo, tu órbita está a cierta cantidad. No sé qué más decir. También nos van a... Ahí está un rover que va a ser para manejar, que sabía ya. Recuerda que en la luna, en el Apolo, también hubo un auto para moverse mejor, que creo que fue para el Apolo 14, si es que estoy bien. También se han podido captar algunas banderas, porque mira, la verdadera pregunta es ¿por qué? ¿Por qué podemos ver galaxias y no las banderas que están en la luna? Están... Mira, las banderas son re pequeñitas, no se ven casi nada, o no sé si se ven, pero las galaxias como Andrómeda son re gigantes. Compárate con el planeta Tierra, como si fuera, no sé, sería el planeta Tierra una naranja con el Burj Khalifa. Imagínate. La Starbase se encuentra en Texas, creo. Sí, Texas. ¿Cómo que Golfo de América? Es Golfo de México. Bueno, cada quien le dice como quiera. Le podemos poner Golfo de los gringos o Golfo de los... Órale, güey. Pero van a hacer una maniobra de entrada. Casi todas las naves, o no sé si todas, lo que hacen es como entrar a la Tierra, a la atmósfera, que salga plasma, después hacen como si fuera una piedra en el agua. Y después comienzan a reentrar y comienza a salir plasma. Y también, por ejemplo, en el Artemis 2, por suerte salió bien la reentrada, pero en el Artemis 1 comenzó partes completas de la nave encontraron trozos que no estaban, faltaban trozos completos. Lo que creo que van a hacer ahora con la Starship, no sé si va a ser atrapar el propulsor o estrellarlo contra el océano y recuperarlo. Recuerden que el vuelo 12 sí o sí se tendrá que hacer hoy día, porque si hay más retrasos tendrían que cancelar el contrato y contratar a Blue Origin. Y lo que estamos viendo ahora mismo fue un mapa de la Tierra de la Starbase donde quedaba y eso. Y ahora estamos viendo el cohete. Debuta la versión 3. La parte de arriba negra es la Starship y la parte de abajo es el Super Heavy. Sale harto humo blanco. Y recuerden que también los cohetes necesitan sí o sí un chorro de agua re grande para que no haga kaboom. Por eso. Bueno, cada vez se suelta más humo y eso. Recuerden que es normal que los cohetes expulsen gas. También pasó lo mismo en el Artemis 2 y cada cohete que te imagines. Porque recuerden que esos tanques se llenan justo en el despegue. Porque mira, se usa oxígeno líquido y hidrógeno líquido, que hace el resultado agua. Y como se conservan a temperaturas pero muy bajas, tampoco como el nitrógeno líquido, pero menos 100 grados por ahí. Si es que estoy bien, el nitrógeno líquido era un poquito más que eso. Y bueno, ese es el equipo de recuperación de restos y eso de SpaceX. Por ejemplo, en el Artemis 1 inflaron esos mismos barcos parecidos. Hicieron un equipo de rescate de fuerza marítima del gobierno, porque es de la NASA, obvio. Voy a tomar agua un poquitito, los voy a dejar ahí. Bueno, esperen. Recuerden que ahora debuta la versión 3. Casi todo creo que es nuevo. Y la probabilidad que veamos fuegos artificiales por el fuego sea alta. Y por eso también, si llegan a perder comunicación, pasa lo mismo que la anterior vez, que les explotó la Starship. El directo está siendo re largo, pero igual, vamos a usar el tiempo que tenemos. Tampoco es que estamos usando Streamlabs, que nos limite tanto el tiempo. Estamos usando OBS Studio, con YouTube, y YouTube es ¿cómo lo podemos decir? Re Libertad, con arte libertad, en esos temas de stream. También estoy resolviendo un cubo Rubik por si tardo en hablar. Pero sí estoy resolviendo un cubo Rubik, así que si me distraigo es porque lo estoy haciendo. Jeje. La idea es juntarlo con esta cara de acá, el cubo Rubik. Capaz el nuevo Sopa Timmy o el Soap Timmy. Como sea que le quieras decir a Sopa Timmy, pero yo le voy a decir Sopa Timmy. Aunque es gringo. 6 horas de stream. 6 horas de stream. Le agradezco a unos nuevos suscriptores, los voy a mencionar por si acaso. Renato Toledo. Ya sé quién es Renato Toledo. También le agradezco a Douglas Sainz Franceschi, o como sea que se diga. Es un amigo de Renato Toledo. Se suscribió. Muchas gracias, Renato Toledo. Te di unas grandes... Es un compañero de colegio. Bueno, nos estamos preparando un poquito más para... ya sabes. El lanzamiento. Tengo una esta que desactiva el micrófono, así que también puedo desactivarlo sin tener que abrir el OBS. Porque mira, me sale cuando tengo abierto el OBS y ahora lo tengo abierto. Y déjame ver si ahora suena algo si lo desactivo. Gran noticia, el cohete está como a 5 minutos de despegar. Recuerden que también se va a frenar, pero ahora tenemos al director de la NASA. Así que también son importantes sus palabras. Y bueno, continuaremos. Yo estoy preparando unos clips, así que estoy grabando ahora mismo. Preparando el lanzamiento. Y recuerden, algún día voy a estar ahí en el espacio. Mira, ahí tenemos a un chino o como qué nacionalidad sea, usando un computador. ¿Cómo sería ser un computador en la Estación Espacial Internacional? La verdadera pregunta. Saldría volando por todo el... Solamente falta el Sagitario A asterisco. He completado una cara. 3 minutos para el despliegue. Ah, no, nada. Ya, tengo un astronauta acá de juguete que refleja en el cielo de mi pieza. Lamentablemente no muestro mi pieza por temas de privacidad. Lo siento, chicos. pero también puede reproducir música y eso. Si se preguntan por qué no hablé por tanto rato y antes dejé el stream ahí encendido, fue porque estaba ordenando mi pieza junto a mi mamá y no se me había dado cuenta que se había acabado la transmisión de un lanzamiento de la Starship y tuve que poner otro. No sé si lo repetí o no. Pero miren, mínimo ahora estoy con ustedes hablando acá. Estamos cada vez menos de terminar de llenarse los tanques con propelente criogénico. Mira, ahora es uno de los momentos que más sale el oxígeno líquido y el hidrógeno líquido. También hay cohetes que usan tanques de gas, también. Eso también es peligroso porque los cohetes también tienen más probabilidades que hagan con un tanque de gas. Y más encima si se está estrenando su nueva versión. Por eso nunca hay que ponerle un tanque de gas a tu cohete si es una nueva versión. De hecho, yo sé cómo funciona un cohete, pero eso es para un próximo video. Les apuesto que les puedo hacer una compilación de 10 horas del espacio. Aunque sería un placer, pero muy largo, pero igual me atrevo. Como dice los comerciales de Pepsi en mi país. Pepsi Cero, atrévete a más. Bueno, 2 minutos para el despliegue, 1 minuto para el despliegue, perdón digo. Se va a detener el tiempo creo ahora, o no sé cuándo. Pero cuando estemos a 40 minutos se va a detener. Ok. El tiempo se ha pausado. Se van a verificar los sistemas del lanzamiento. Si llega a salir algo mal hoy día y se llega a abortar el sistema, no hay más lanzamiento por hoy día. Pero también lo más probable es que si hay más retrasos. Ya, sigue el timer. Gran noticia, el cohete está a 30 segundos de despegar. Gran noticia, el cohete está a punto de despegar. Es el cohete más potente que SpaceX haya lanzado jamás. Con nuevo debut. ¿Ok? Ahora vamos. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignición. Y despegue. Tenemos despegue de la Starship versión 3 hoy día. Llevamos ahora 10 segundos más de despegue. La Starship ahora va a ir hacia el espacio. Ok, se han encendido los 33 motores con éxito. Ya llevan 7 kilómetros. Ok, ya llevamos un minuto. Ya se está balanceando, creo. Veamos si SpaceX tiene la oportunidad de ser contratado por la NASA. O aumentó mucho la velocidad. Aumentó muchísimo. Ok, se han desactivado un motor. Un motor ya dejó de funcionar. Ok, se bugueó. Ya, hay que... Ya. Ok, ya están funcionando menos motores. Ya lograron, creo que, escapar de la atmósfera. A una super... Ya. Se ha desacoplado el Super Heavy. Ahora la Starship se está preparando para ir al espacio. Ahora está reentrando el Super Heavy. Ok, ya dejaron de funcionar todos los motores del Super Heavy. Ahora veremos cómo entra la recuperación. Ahora tenemos los 6 motores de la Starship funcionando. Ok. Veamos si la competencia de SpaceX le gana. O sea, Blue Origin. Ahora está reentrando el cohete, como estamos viendo ahora mismo. Ahora... Oh, mira. Ya se está inclinando, ya. Recuerden que va a estar como entre el Golfo de México y cerca de la Starbase, el recupero. Recuerden que va a ser parecido. Oh, ya dejó de funcionar un motor de la Starship. Ojo, de la Starship, no del Super Heavy. Starship. Ya se separaron. Super Heavy Landing. Ah, ya entendí. Ok, ya. Y vamos bien. Anda disminuyendo el del Super Heavy. Recuerden que también se puede usar para la reentrada de estos motores de la Starship. Altitud 66, ok. 65. Antes falta que salgan de la línea de Karman. This is Starman on the sky. Ok, reentra. Ya sí puedes entrar, sí, ya puedes entrar. 5 minutos del despegue llevamos y ya se están preparando para entrar. Ojo, y no creo que vaya a salir plasma, porque si no estaría acabada la Starship. Yo creo que van a hacer una técnica. No sé, pero como es debut, mínimo hoy día no vimos fuegos artificiales. Menos mal. No vimos fuegos artificiales hoy día. Ok. Oh, está bajando, ¡Oh! Mira, ya está saliendo de las nubes. Estamos viendo ahora mismo. Llevamos 6 minutos de grabación. Y llevamos 6 horas de transmisión. Ok, esperen. Ok, la Starship se está preparando para la entrada también. Ok, 6 minutos ya del despegue. 0 la altitud, el Super Heavy. Ok, yo me voy a encargar de grabar los momentos claves. Después voy a editar todo esto y lo voy a hacer en clips. Y después me voy a encargar de ver todo. Recuerden que yo no me están pagando ni nada. Solamente estoy haciéndolo porque me gusta la astronomía. La Starship está legalmente en el espacio. Ok, ya están haciendo ignición los Raptors. Recuerden que hay unos motores que tienen más función que los demás. Hay unos más grandes y otros más pequeños. Porfa, SpaceX, no más baldosas, por favor, no pongan más baldosas. S-39. Ok, 8 minutos llevamos. Y acá llevamos... Ok. Bueno, están legalmente en el espacio, así que no podemos decirle nada malo. Están reentrando. Un vampiro vegetariano. Vampiro vegetariano. Recuerden esto es el futuro para la humanidad, el futuro de la Luna y de Marte. Mi procesador se calienta mucho, que sirve para hacer carnita asada. Recuerden, el domingo también hacemos stream si se lanza la misión Starlink. Una de las varias Starlink Mission que han tenido. Cuando es Starlink Mission es porque se van a lanzar satélites Starlink. No que se vaya a lanzar, no sé, una Starship de nuevo, no. No teníamos el lanzamiento de Starship desde octubre del 2025. Así que mejor. Me acuerdo que en la 2021 se anunció la Starship y después comenzaron en 2023 a hacer las pruebas. Llevamos 10 minutos del despegue y 10 minutos de grabación. Esto lo voy a hacer harto fit de shorts. Ahí están todos celebrando en SpaceX. Arriba tienen una bola de Marte, porque el futuro es Marte para ellos. Se van a liberar los Starlink. Se están liberando los Starlink. Ojo, pronto se va a revelar la tripulación para el Artemis 3. Hay probabilidades que no sean los del Artemis 2. Ahora, ¿cómo voy a ver las vueltas de Victor Glover? Bueno, siempre que eso es el mismo peluche, está bien. Ok, 11 minutos llevamos. 156 de metros. Creo que ya liberaron los satélites Starlink, así que vamos a conseguir igual líneas de imágenes. Así que pronto van a hacer las entradas de la Starship. Así que... aunque total, están ya en el espacio y no quiero ningún terraplanista, ¿ok? Ok, la Starship hoy día salió bien. ¿Qué pasa? Chicos, ¿les gustaría que hiciéramos un directo infinito? Para el futuro. Voy a hacer un video de un pan cayéndose y no lo voy a cortar nunca. Yo lo voy a cortar cuando se me dé la gana. Cuando se me dé la gana. 12 minutos de tiempo de más. Ahora estamos viendo las imágenes por el Starlink. Fácilmente yo le podría dar al botón de terminar emisión y ya, listo. Y no quiero, porque también tengo que cerrar el directo de Kik. Y no quiero eso. Oigan chicos, pueden seguirme en Kik o también suscribirse en Kik. Cualquiera de los dos me sirve. Oye amigos, no sé si no me voy a comer esa publicidad que me hicieron, pero me dijeron: hola amigos, sé crecer tu Kik. No sé cuánto, es difícil, te ayudo. Con 1500 seguidores reales, 100 viewers por stream, 25 subs y 250 chats reales. Y me dieron un Discord, pero yo no uso Discord, así que no pienso dar nada y nada. Ok, por favor. Yo no quiero hacerlo a la injusta, yo quiero hacerlo justo. Yo pienso seguir los caminos de algunos youtubers, como por ejemplo Hola soy Germán, Misa Sinfonía. Ellos crecieron por su cuenta, no usaron bots, amigos, no me ofrezcan bots. Yo no voy a querer bots, ni no te creo que vayan a ser reales. Por si acaso, YouTube algún día va a prohibir los bots. Y todos esos seguidores que eran bots, el stream de Audio Speed que eran bots, también. Ya, están filtrando. Ok. Recuerden que cuando reentran, lo que hacen es romper moléculas de aire y por eso se van a crear plasma. Pero ¿para qué voy a querer bots? Esa es la verdadera. Oigan chicos, mañana hacemos un solo chateando. Sí, voy a hacer un solo chateando. Ok, 15 minutos. Tenemos 2 viewers. Wow. Llevamos 5 horas de stream acá en Kik. En Kik está más como en tiempo real, así que por eso estoy viéndolo por Kik. Voy a tratar de configurar igual en YouTube para que sea en tiempo real, para que así se pueda. Ya. Cada vez llevamos más. Como casi a los 20 minutos ahí va a ser la entrada, creo. Así que por un rato me voy a ir. Los voy a dejar ahí. Bueno, voy a seguir con mis cosas. Voy a estar un ratito haciendo mis cosas. no me he perdido nada, creo. ¿Ya qué es eso? Están en el espacio, ¿cierto? Bueno, sigamos con el stream. Bueno, en el kick estamos atrasados como unos 50 minutos, creo. Así que no es tanto. Van a entrar, ¿cierto? Ay, ay. Bueno. 20 minutos y no fue entrada. Bueno. Yo voy a estar traduciendo lo que dicen por mientras. Me voy a poner a traducir porque sí, ¿ok? Esperen, déjenme... No sé cómo conseguir unos subtítulos, pero igual. Quiero... Bueno, no puedo. Bueno, nos estamos preparando para la siguiente fase. Están ya por Brasil y las Guyanas y Surinal. Pacheco, cara floja. Me volví viciado a los videos de Pacheco cara floja. Bueno, yo me voy a quedar hasta la entrada, así que cueste lo que cueste, yo me voy a quedar a la entrada. Me voy a estar preparando yo me voy a preparar porque quiero hacer un directo muy largo. Lo voy a terminar cuando se me dé la gana. Aún no veo ninguna parte que diga entrada ni nada. No sé qué decir, pero por mientras me voy a quedar calladito esperando alguna fase. Llevamos 30 minutos, bueno, casi 30 minutos y ni un solo entrada. No sé qué están haciendo ahí. Creo que se están liberando Starlings. Por lo que decían, la luz. Recuerda que también en el espacio igual es peligroso porque sale el micrometeorito, está la radiación cósmica y eso. Creo que ya no le queda nada al Starship. Creo que ya están vaciando todo lo que está allá adentro. No sé qué es lo que están haciendo. Ok. haciendo lo mío. Pero ya saben. Ok, llevamos 30 minutos después del despliegue. Y nada. Ok. Ya están cada vez menos. Se nota a veces los reflejos del sol. Así que Ok, ya vamos casi por los 35 minutos y ni una sola entrada. No sé qué es lo que estarán haciendo ahora mismo, pero se están tardando muchísimo. Lo juro, se están tardando muchísimo. La Starship ya debe haber entrado. Ya soltaron todos los estables. Estoy perdiendo señal. No sé si se perdió por partes, pero bueno. Yo por ahora voy a estar preparándome. Voy a cortar grabación. Ok, nos estamos preparando para la reentrada del Artemis 2 de la Starship. En 45 minutos y ya estamos entrando. Ya no estamos legalmente en el espacio, pero sí, ya estamos entrando. Solamente falta volver a entrar de la línea de Karman. Ya tendríamos todo listo, los de SpaceX. Y bueno, yo creo que van a estrellarlo contra el océano y recuperarlo. Pero tampoco pero es que tampoco es que lo vayan a hacer que lo estrellen contra el océano y eso. No, no. Yo creo que lo van a hacer así como tipo así como lo hicieron con los anteriores modelos. Por ejemplo, cuando recuperan la cosa que trae la carga útil del Falcon 9, similar. Y por eso ok, ya estamos en altitud ya casi baja. Un poquitito más y ya volvemos a la línea de Karman. Ahora esto se está viendo por los Starlink. Van a capturar igual lindas imágenes. También lo más probable es que lo que está alterando todo esto es la radiación cósmica. Los voy a explicar cuando haga la compilación de 10 horas del espacio, pero primero tengo que hacer videos sobre el espacio y eso. Porque si no, ¿qué tendría sentido hacer una compilación ya hecha al instante? Hay que hacerlo por partes, como lo hace Solarverse o Solarverse, como sea que se llame. Ok, yo me voy a preparar. Yo no voy a hablar cuando entren, antes me estoy quedando calladito, así que no voy a decir nada, ok. Nos vemos por unos minutitos. Voy a seguir viendo la entrada, obvio. viendo por el Starlink. Bueno, ya estuvimos viendo cómo sigue descendiendo. Sigue descendiendo, aún no se ven las nubes. No se ven las nubes, pero aún no se ven así como lo que vemos nosotros. Ya, se aproxima la Starship Landing, lo que principalmente sería la entrada, creo. Ok, 9 metros y ya, 9 kilómetros y ya entran a la línea de Karman. Cada vez menos para la línea de Karman, o sea, ingresa de nuevo a la atmósfera, porque existen unas otras atmósferas más después de la línea de Karman. Esa es la principal atmósfera, porque también existen otras atmósferas un poquito más lejos. Pero bueno, ok, entraron a la línea de Karman, oficialmente en la línea de Karman, de Karma. Llevamos 7 horas de en vivo. $20 kilómetros. Cada vez menos para el splashdown. Oh, mira, 1.000.000 con 1.000.000 con 2.000 viewers. Un millón, 2 viewers. Wow. This is so nice. Ay. Ok, están unos kilómetros. Dios. Esos son unos kilómetros nomás. Igual es medio difícil. $2 kilómetros. No sé si sea tan confiable este sistema, pero igual voy a confiar por ahora. Mira, están soltando ahí combustible y eso. Bueno, vapores. Mira, acá estás viendo las nubes, lo que está formado por agua y gas. Ok, splashdown. Se aproxima el splashdown. Splashdown del Starship. SpaceX recupera uno de sus cohetes con éxito. Explotó. ¡Explotó! Ok, el cohete explotó. Mínimo salió bien de los Starlink, así que igual estará bien. Está bien, aunque explotó, igual le salió bien la jugada y eso. Bueno, explotó igual. Hizo kaboom. Bueno, no vimos fuegos artificiales, menos mal, ni nada de eso. Y todo salió bien por ahora. Salió la misión completada. Missions complete. Gracias a los que estaban viendo el stream. Voy a dar unos saludos especiales. Por si alguien lo estaba viendo, por si acaso. Igual. No sé si alguien lo estaba viendo. Espérense. Ok. No. Bueno, pero gracias a los que lo estuvieron viendo. Y a los nuevos subs, en especial a Renato Toledo y a Douglas. Muchas gracias. Recuerden, pueden llamarme Spawn. Recuerden, nunca sabemos quién es el verdadero astronauta. Recuerden. Voy a estar preparando unos videitos también. También le agradezco a Nina-de Killer 337 que comentó pero Spawn. Muchas gracias, Nina de Killer. Muchas gracias. Recuerden que el domingo hay transmisión y recuerden que SpaceX cada vez está más cerca de ser contratado por la NASA, o no sabemos si va a ser Blue Origin, pero cada vez más estamos cada vez más cerca de saberlo. También le doy gracias a Bonnier, nuestra moderadora oficial, también a Jans Z Gamer XZ por comentar hola y ser el número 2 en la tabla de clasificatorias de fans, y también @solori fan agüita o fan ya agüita, no sé cómo se llama, pero muchas gracias a todos los que estaban viendo. También les agradezco a los que estaban viendo el stream. También les agradezco a todos los que se suscribieron también. Recuerda crecer esta comunidad cada vez más. Recuerden que próximamente vamos a estar en Marte. Mañana en el Opera GX por Forsaken me dan una skin de chance. Yo quiero la skin de One X. Tengo que esperar hasta el día 7. O sea, tengo que esperar el próximo miércoles. Os voy a finalizar la encuesta. Muchas gracias. La encuesta ganó. Gracias a los que estaban viendo. Ya. ¿O no, amigos? Bueno, próximamente estaremos preparados para más. Bueno, recuerden, muchas gracias por todos los que estaban viendo. Y también recuerden seguirme en Kik. También recuerden que el domingo hay directo. Y también me voy a encargar de que cierre ustedes. Les dejo una bonita pantalla de SpaceX. Yo me voy a encargar de cerrar el stream, con permisito. No le voy a cerrar al tiro, pero me voy a encargar de cerrarlo y ya. Bueno, ya se acabó el lanzamiento y mañana vamos a hacer un directo también, más un video sobre el Starship, ¿ok? Muchas gracias a todos los que estaban apoyando el stream y nos vemos hasta la próxima. También muchas gracias a Nina de Killer y a Renato Toledo y a Douglas por suscribirse y comentar. Gracias.